Joe Rogan Podcast. Check it out.
The Joe Rogan Experience.
Train by day, Joe Rogan Podcast by night, all day.
And we're up. What's up, man? How are you?
Yeah.
Pleasure to meet you, sir.
Pleasure to be here. Thanks, Joe.
I really enjoy your content online. It's been really fascinating. So I've been doing a deep dive into a lot of your videos over the last few days and enjoying the hell out of it. And particularly enjoying... I wanted to talk to you about so many different things, but one of the most pressing things, one of the reasons why I wanted to bring you in, because you are very knowledgeable in all things space, is the James Webb Telescope and all the different stuff that they've been finding, particularly about these galaxies that were formed very shortly after not shortly, not within our lifetime shortly, but cosmologically shortly after the Big Bang. That it seems like we have to figure out why these things are forming. Is the universe older? There's all this different kind of speculation. Maybe the Big Bang is not 13 point whatever billion years old, but maybe 22, 24. Like, what is your take on all this?
Yeah, the James Webb Space Telescope is such an incredible instrument. The data has just blown us away. When you build this thing and you look at it unfolding in space, you think there's so many ways it could go wrong that we all were just like, this, I think it was 215 moving parts or something had to unfold. So, just the fact
in space.
The fact it just all worked was just remarkable.
Right.
And then when we got those first images, they just kind of blew us away as well, because we had sort of these engineering expectations of what it would do, but the data was just even better than that. So when it, of course, the first thing you want to do is point it to the most distant part of the universe and see what's out there in those darkest patches. And so when it did that, it started finding a couple of things. It started finding quasars, which are kind of the center of these very active galaxies. These are supermassive black holes that have loads of crap falling in, and they're spewing out all this energy. They're kind of feeding supermassive black holes. And so we started detecting those way earlier than we thought the universe should be able to build them. Because to make a supermassive black hole, these things are like 100 million solar masses. Imagine that, 100 million suns have not only been born but died, gone through their entire life cycle, died, collapsed into a black hole, and then those black holes have presumably somehow merged together into this super behemoth of this 100 million solar mass thing. So we're finding those just, 300 million years after the Big Bang. And that was like, hold on, that doesn't make any sense. Like, how can this be? And similarly with the galaxies, we were seeing these images, these galaxies, and you can date roughly how old they should be based off the redshift. So the universe is expanding. So therefore, if something is very far away from us and the universe is expanding, its light gets stretched more and more and more as it journeys over space. And so we can use that redshift to kind of date how old these things are. When we use those dates, we look at these images, again, they seem suspiciously too old. You really shouldn't be able to form these things that early on in the universe. And so that kind of puzzled us. I think for the galaxy thing, there was a bit of a resolution there. One of the resolutions is that we probably miscalculated how easy it is to form these galaxies in the first place. So we had these models for galaxy formation, we had these models for how stars should form, how quickly they should live, but it was all essentially calibrated on what we see around us, like right here in this part of the universe, in the local universe. And then we kind of realized that those same models probably need to be tweaked if you're going to apply them to the early universe, where the density is so much higher, the gas temperature is much hotter, everything's just completely different in the early universe. So when you kind of make those corrections, it actually looks like maybe it's actually possible to make those galaxies earlier than we thought. So I think the galaxy problem is a bit easier to explain. I think the quasar problem to me is more interesting. How do you get those supermassive black holes so early? There's a certain kind of maximum rate you can feed these things called the Eddington limit. And that's sort of you throw mass into a black hole and so much energy is going in, some of it spews back out. And the energy which spews back out stops other stuff coming in, right? So there's a maximum limit. You can't build a black hole faster, in principle, than this Eddington limit. And yet, when you do the calculation, these black holes must have been fed what we call super Eddington. So faster than Eddington. So something's wrong with our models, right? Either we've got the universe age wrong, which I think is possible, but I would say that's probably a much less likely solution, or we've got the astrophysics wrong.
Why do you think that the universe's age is a less likely solution?
Because we've got this, like in particle physics, you've got the standard model, which includes like all the particles and the electron, the baryons, all these kind of stuff. And in cosmology, we have a similar kind of model. It's called lambda CDM. And so the lambda stands for dark energy, and the CDM is cold dark matter. So this is our standard model, and we have used it to explain so much stuff in the universe, Joe. I mean, we're talking about the cosmic microwave background, oscillations in the sky, these baryonic acoustic oscillations, the stretching of the universe, Cepheids. You can use it to explain so much stuff, and it works beautifully. I mean, it works down to like the 0.01% level. So if you say the universe age is wrong, you have to give that up. So maybe it is wrong, but if you give that up, you have to come up with a radical new idea, which can now explain all of this stuff at that same level of precision. The much more likely answer, in my book, is that astrophysics, like the gas swirling around, the plasma colliding with each other, that's just more complicated in my mind than the actual model of just the simple expansion of the universe, which actually is a fairly simple geometric model.
Fairly simple in that you can use whatever methods that we're using currently to measure everything that's out there, and it makes sense.
Yeah.
But if we're using something like the James Webb Telescope, so we're getting a much deeper view of the universe, how limited is the James Webb in comparison to James Webb 2.0, 3.0? Like, are we going to have to continually revamp what our understanding of this process is?
Yes, we will. And that's
exciting.
That's what I love, right? That's
Isn't that
what scientists love. Every time we've built a telescope that is, 10 times more precise than the last thing, every time we've done that, we have been surprised. And so these early galaxies are a good example. The cosmological experiments that are going on now, one of the big surprises is this thing called the Hubble tension. Have you heard of that? Hubble tension? So Hubble tension is measuring the expansion rate of the universe. How fast are things flying apart? And you can do it two ways. You can use the cosmic microwave background. So that's the earliest radiation that we can detect. This is that stuff that's about 3 Kelvin warm. You can detect in the microwave. And this is the light which has traveled basically when the universe was 380,000 years old. It's that light, and we see it in all directions. That's how we know the Big Bang kind of didn't happen in one place. It happened everywhere, because you just see this light coming in from all directions. And from studying that radiation, you can kind of get a model of the universe, and then you can calculate, using this model, how fast should the universe be expanding today if I run the clock forward. And you get a number. And then, if you do that same experiment but locally, you actually measure the stars. You measure the supernovae around us, these pulsating stars, and you actually measure how fast is stuff expanding, you get a different number. They don't line up. And so this is really weird. So somehow, something's wrong, right? Either our measurements of the local universe must be wrong in some way, or this model that we're using to calculate the whole history of the universe, something is wrong with that model. So this is a very famous growing problem in cosmology. It's now what we call a 5 sigma level. So that means the chance of this being random is just like 0, essentially. It's just this is a real effect. And now we just have to figure out who's wrong. Is it the observers or is it the theorists?
Wow.
Where do
you fall on this?
Yeah, it's hard. I swing between both ways. I'll talk to my cosmology colleagues, and they'll, depending on who I talk to, they'll convince me either way. So I think
that's disturbing that people are convinced. If these new telescopes keep showing us this new puzzle, it's it always bothers me when someone is like rigidly convinced.
Everyone has a certain pet theory, right?
Bias.
They're trying to push. We all have biases, right? Yeah. So
human beings.
Yeah. I mean, it's hard, right? If you've spent 20 years of your life, most of your academic career, studying this one thing, it's really hard to turn around and say, you know what, I screwed up. Right, the last 20 years of measurements, they were all wrong, and I have to eat humble pie. That's not easy, but it has happened in some cases. One of my favorite stories about this is the first exoplanet that was ever claimed, a planet around another star. One of the first ones. It was wrong. So it was a pulsar that had a supposed planet around it on a 6-month orbital period. So exactly half the Earth's orbital period around the sun. And they saw this signal in their data, this pulsating star was doing something weird, and they figured out there was a 6-month period around it. So the dude published this paper, Matthew Bales, brilliant astronomer, and he realized later on it was wrong. And instead of it being a real planet, he hadn't quite corrected the orbital eccentricity of the Earth. So the Earth is not on a circular orbit. Its eccentricity is 0.0167. It's a tiny number, but that number hadn't been accounted for in the calculation. And so he had to stand up in front of hundreds of astronomers at this famous IAU meeting, and he admitted he was wrong. And he got a standing ovation.
Oh,
for
good
doing
for him.
It. It's
Yeah.
awesome. It's one of the few times I've heard of someone doing that, and I think it's dope. I think we need to encourage people to
Well, with
concede
something that's so massive and is such a puzzle, this is just bound to happen.
Yeah.
If you get people that are rigidly attached to their belief systems in terms of like a very limited understanding of a fantastic thing that is almost beyond imagination when you think about the sheer size of the universe and the age of the universe. I mean, when we were talking about aging, when we say 13 billion or 22 billion, those numbers don't even register in your mind. They're not real.
Yeah.
You know what I mean? It's like that you see a 1 and a 3 and you kind of get it, but you don't get it. There's no way.
You can't intuit it.
No,
Yeah.
it's not possible for our puny little minds to imagine 13 plus billion years. It's just too crazy. So if you're rigid with that, like, God, man.
Yeah.
Like,
I mean, part of the journey of being a scientist is knowing what your own biases are. And I remember, one of my threads of my career has been trying to look for exomoons, moons around these exoplanets, which would be a first if we got them. So that's, it's a big deal, right? If I succeed at this, there could be like, golden prizes, award ceremonies. Like you kind of get that glimmer in your eye, like, oh man, this I could be memorialized for this success. And so that's alluring, right? That's tempting. It's like kind of the same temptation as fame. And I remember once we had this signal. It was Kepler 90, PH2b was the name of the planet. And we had this signal, and it kind of looked like just what we expect for an exomoon. And I remember I was so excited. I was at Harvard at the time, had to walk out the building, had to go to a park bench, and I had to just take like deep breaths. I was like, this could be it, This is the thing I've been searching for.
That's
and
awesome.
I was like almost hyperventilating with excitement. And then I remember in that
that's
moment.
how you know you're in the right job.
Right.
Right?
Yeah. The
Like
passion
that is
was
the
there
job
for sure.
you. Yeah.
And I remember thinking to myself after calming myself down a little bit, I want this to be true too much. Like this is, of all the people in the world, I want this to be true the most. So therefore, let's flip that round, and I'm going to have to be the greatest skeptic of this thing because I know I want it to be so bad that I have to correct the other direction. And it ended up being bullshit. I mean, it ended up being the telescope just misbehaved, had this weird effect called a sudden pixel dropout effect. This weird anomaly happens 1 in like 100,000 times, but it just so happened to pop right then, right there in my data.
What do we know about the consistency of solar systems and galaxies being formed? We know they vary in size. Do we understand why? And we understand what causes them to form in the first place?
Yeah, we're still learning that. We had this picture before we started finding exoplanets that everything would just be like the solar system. We have these 8 planets, circular orbits. You have the rocky planets on the inside, the gas giants on the outside. And we came up with this really elegant theory, this kind of nebula theory to try and explain that. And did a great job, explain everything. But then as soon as we started finding exoplanets, one of the first type of exoplanets we found was these hot Jupiters. So these are Jupiter-sized planets, which are about 20 times closer to their star than Mercury is around the sun. And when those were first announced, nobody believed them. People were like, you can't get a Jupiter there. Like Jupiter's supposed to be 5 AU. How do you get it parked almost onto the surface of the star? It doesn't make any sense. None of the planet formation models could explain that. And it took until we found about 10 of them in a row that people started slowly changing their minds. And the proof of the pudding was when one of them eclipsed its star. So one of them actually passed right in front of the star, right at the moment it was supposed to, and we saw an eclipse. And when that happened, everyone was like, all right, this is real. But then we had to figure out how the hell do you do that? So there was a long skeptical curve to get to that point. And now we think the way to make those things is there's probably Jupiter's on the outside of the solar system, they come too close to each other, they gravitate, like kind of wrestling almost, they kind of excite each other. One of them gets kicked out in a random direction, and it can get flung into a highly eccentric orbit. And a highly eccentric orbit over time will circularize. So it doesn't want to stay on an eccentric orbit, it wants to turn into a circle through the tidal interactions with the star. So these things probably circularize really close onto their stars. But this is unusual, it only happens about 1% of star systems, we see this. But it's an example of how diverse things are. Another example is mini Neptunes. You ever heard of those planets?
No.
So mini Neptunes are these planets which are in between the size of the Earth and Neptune. Neptune's about 4 times bigger than the Earth. So these things are about twice the size of the Earth. We don't have anything like that in the solar system. So we don't know what it is. Is it a big rock? Is it like a super Earth, a mega Earth? Or is it a scaled down version of Neptune? Is it like an ocean world maybe of some kind? And turns out that planet is the most common type of planet in the universe, as far as we can tell. And we don't have one.
Wow.
So that's kind of weird, right? I mean, it seems like there's so many aspects of our solar system that are unusual. Even having a Jupiter, only 10% of stars have a Jupiter, as far as we can tell.
10% of how many stars that have been observed?
Oh, at this point, I mean, we've observed hundreds of thousands of stars, and we know of about 6,000 exoplanets. So of that population, you correct for the statistics, correct for the ones you've missed. Even so, I mean, these Jupiters are the easiest ones to find, right? They're the big boys. They're easy. They wobble the star a ton, so they're pretty easy to spot. So we're pretty confident that sun-like stars, it's kind of not typical for them to have these Jupiter-sized planets, and we've got 2 of them. So that seems interesting, right? To our own origin in this solar system. And similarly, having 8 planets, that's pretty unusual. We don't see many systems with that many planets packed together.
How many solar systems are binary solar systems as opposed to having a single star?
Yeah, about half of all stars live in binary systems.
Really?
It's very common. It's actually Alpha Centauri AB. That's the nearest star system to us. And it's actually a trinary. There's Alpha AB that go around each other really close. And then there's Proxima Centauri, which is on the outside. And actually just this morning, Joe, there was an announcement of a giant planet around Alpha Centauri. It's a candidate. We don't know if it's confirmed yet, but it's kind of in the habitable zone, so the distance where, in principle, you could have liquid water on the surface of a rocky planet.
So it is a candidate for a planet? Or like it
Yes.
has been, so it hasn't been completely confirmed.
James
that it's a
Webb
planet?
just spotted it. James Webb spotted it just come out today. So there's 3 photos that James Webb took. Maybe they'll be in this article somewhere. It took 3 images, and in one of those images, it captures an actual photo of the planet. You can see the planet in direct light. That's how powerful James Webb is. And it's a nearby star, so it's easy to image. Yeah, right here. So that S1, that's the planet you're looking at.
Wow.
So you can see you have to block out the star in the middle because the star is like 1 billion times brighter than the planet. So you have to suppress it with all this advanced coronagraph technology that James Webb has. But when you do that and you zoom right in, you see this little planet there. Actually, it's probably about the same size as Saturn. It's probably a big boy.
I love how they went with the real clickbaity headline with Avatar Planet. The other article that you pulled up.
I was quoting that one. So I know
planet from the Avatar movies may exist in real life. Like, shut up! You're just trying to get people to click on that. It's kind of weird that they have to do that. But like, this is the world we're living in now. Everyone has such a short attention span.
Right.
You're funneling through your Google feed. Like, what's new?
Yeah, it's got to connect to something pop culture. Otherwise, people are like,
Yeah, it's got to get you somehow. Like, there's some editor.
It's probably more like the 3-body problem. The books and the show is the Trisolarans, and they live there. So there's the 3 stars, Trisolaran, and the dynamics is so crazy that it pushes these planets into these highly eccentric and twisted orbits, and that's exactly what this planet appears to be. So this planet actually looks more like, rather than Avatar, it actually looks more like Trisolaran or Solaris, whatever it's called.
Pull that article back up again, please, Jamie. The second one, the one that was less clickbaity. So how large is this planet, this S1?
It's hard to tell. It looks like it's about 100 times heavier than the Earth. So that's about Saturn.
Wow.
Roughly Saturn. But it's only a candidate, right? So we need to get more images of it to confirm that it's real. So I'm sure James Webb will point back at it. But, I mean, look at it. It looks pretty convincing. I mean, how do you get that big blob of light sat there? So I think the signal to noise is really good.
So because they vary so much in the way these galaxies and the way these solar systems are constructed, do we know why they're constructed in the first place? Like, why do they form in that way? Like, why does Bode's law work? Does it still work?
It kind of works, but it makes some bad predictions.
Can you explain Bode's law?
Yeah, so Bode's law is essentially looking at the separation between the planets in the solar system. So Venus, for instance, Mercury is about 0.4 AU. Venus is 0.7, the Earth is 1, and Mars is 1.5. So there seems to be a pattern, and I think it's like a fraction of 1.5 or something in terms of like take the last one and just multiply by 1.5, and you roughly.
And
get
is
to the
it
next one.
dependent upon the mass of the planet?
No, it's just purely their spacing. So it was it has some problems though. It doesn't particularly work that well. It predicts there's a planet where the asteroid belt is, and obviously there isn't one there, but maybe you could argue something
That's probably
happened,
why the asteroid belt's there, right?
You
Doesn't
could
that
argue,
make sense?
yeah.
This episode is brought to you by Uber Eats. Summer is here, and you can now get almost anything you need for your sunny days delivered with Uber Eats. What do I mean by almost? Well, you can't get a well-groomed lawn delivered, but you can get chicken parmesan delivered. A day in the sun? No. A bottle of rum? Yes. Uber Eats can definitely get you that. For almost anything delivered with Uber Eats, order now. For alcohol, you must be legal drinking age. Please enjoy responsibly. Product availability varies by region. See app for details.
But then more problematically, people have tried to apply this to exoplanets. So you've got these multi-planet systems, and we know of like maybe 3 or 4 planets, and there's gaps. And so you can say, okay, let's use Bode's law and predict, okay, there should be a planet right here. And then people have done the observations, they've like dialed in and put all the telescopes on and be like, where's that planet? Sometimes they found the planets there, but usually not. It's not that predictive.
How common are asteroid belts?
We don't know. We can't detect asteroid belts.
Right,
They're
that's
too
the
small.
question. So in these gaps where a planet should be, what if there was an asteroid belt in every one of them?
Yeah.
That would kind of change everything,
That'd be
wouldn't
wild. I'd love that. Yeah.
Yeah.
Then we'd be back to Bode's law.
Yeah.
I mean, but Bode's law, I guess it's actually really a statement. There was a great dynamicist at Princeton, Scott Tremaine, and he showed this, that if you just try to pack planets as close as you can, like just shove them in like sardines into the solar system, some of them will become unstable and just get kicked out. And the ones that are left will follow Bode's law. So it's not so much a statement of like, you know, some deity is putting these planets at the right places. It's that if you just cram stuff in as much as you can, that's what you end up with. Like you just can't cram planets any closer together.
So what is our current belief system when it comes to the formation of solar systems?
It appears to be very common. I mean, when we look at the data we have from the Kepler mission, NASA's extraordinarily successful mission, it detected itself something like 4,000 exoplanets. And that tells us that on average, every single star has a planet. So as far as we can tell, it's pretty hard for a star not to have planets. It's like par for the course for that to happen.
Right.
That was a big breakthrough. The second thing is, as we kind of alluded to, there's a huge diversity in them. And the actual story we normally describe for how they form is that there's some, giant molecular cloud, we call it. So basically a giant cloud of hydrogen in space. Stuff that could have been blown off from a previous supernova or something, or maybe even in the early universe, just primordial gas from the Big Bang, just this leftover hydrogen gas. And if there's be some areas where there'll be slightly higher density and some areas where there's slightly lower density just due to random fluctuations, and the higher densities will self-gravitate. So gravity wants to make, it's like a greedy algorithm, wants to make everything get denser and denser and denser, super greedy. It's relentless, gravity. It never stops. And that's why eventually we end up with black holes, right? Because it just refuses to lose black hole. Gravity just always wants to win the game. So eventually these clouds collapse. And the thing that stops them from collapsing into a black hole is that you start getting fusion in the center, right? Because the temperatures get so hot as you compress this gas that you basically make a star in the center. And the stuff that's left over on the outside, that disk of material, because the star kind of blasts out of its poles and kind of pummels all the gas from north and south, you end up with a disk of material, the centrifugal forces, like spinning a pizza ball, which kind of force it into a disk. And then from that disk, you start to coalesce again. Just some areas are slightly denser, some areas are slightly less dense, and gravity again takes over and starts to collapse things together. So we have this story, but there's lots of parts of the story that we don't understand. So we know how to go, for instance, from pebbles. If you start off with pebbles and imagine them kind of bouncing around, we can imagine sticking them into boulders. And we kind of understand how that could happen, but we don't quite understand how to do some of the steps, like go all the way from dust, which presumably at one point it was just dust. How do you go from dust all the way up to pebbles, all the way up to these boulders, all the way up to planetesimals? That whole story we don't understand. We've got bits of it where we think we understand it, but the whole thing we don't.
Are there any working models or any?
Yeah, this is a
theories?
huge active area of research. People are simulating dust on supercomputers, trying to stick it together, figure out what happened. But it's chaotic. I mean, you've got trillions and trillions of particles of dust randomly moving around, and solving the equations to calculate their motion is one of the most challenging things ever. Maybe AI will help a big part with that.
That would be interesting. Is it also a factor of the size of the sun? Like our star is fairly small in terms of what we know about the universe. One of the most amazing videos that I tend to send people online is the video that shows.
I know the one you mean.
You know, it shows Earth in comparison to our star, and then it shows our star in comparison to slightly larger stars. Then it goes on and on and on till you get to like Betelgeuse, and you get to some of these.
Wild.
It just gets so crazy.
You're like, it's got to stop at some point. It just keeps going.
It's like a galaxy-sized star. Like, what is that thing? It gets so nutty. It's so big.
It's strange, yeah. Yeah, I mean, our star is, I mean, those big stars, those are actually rare, right? So those are the giant stars of the universe, and most stars are not that big.
What is the biggest one that we found?
Oh, I don't know the name, but yeah, I think you're talking about stars which are probably filling up to the orbit of Jupiter type size. Yeah.
So from here to Jupiter.
Yeah.
Oh my God. Just imagine a star from our sun that goes all the way out to Jupiter.
It's nuts. Yeah.
Wow.
And these things are barely stars at that point. Like if you could zoom in a spaceship and look at the surface, the gravity would be so weak at that point, right? Because the mass hasn't changed of the star. In fact, if anything, it's lost mass. So it's barely got enough gravity to hold that thing together. So the thing is like fluctuating. It's like a giant sheet that someone's waving up and down. So that's why those stars have these wild fluctuations in brightness, because they're just kind of undulating on their surface.
What is this one, Jamie? Is this the largest one?
That's the name of the biggest one, I guess.
Stevenson 218. What is the little tiny one in the far left?
That's our sun.
It's so crazy. Look how big that there's.
Yeah.
Look at our sun in comparison to that thing. Oh my God.
And what's crazy is that the most common type of star in the universe is even smaller than the sun. So
really?
The most common type of star in the universe is a red dwarf. 75% of all stars are red dwarfs. Only 10% of stars look like our sun. So already that's kind of odd. You kind of think, all things being equal, how come we don't live around a red dwarf?
Right, and what is causing one to be so massive and another solar system, fairly close to it to be small? And like, what is?
Yeah, the difference is it's always easier to make a small thing, right? It's kind of like having crumbs down your sofa or something, like breaking up, right? It's easier to have small, dusty things than it is to have huge pieces of cookie still left in the bottom of your sofa. So generally, it's pretty hard for the conditions to come together to make a gigantic, supermassive star. In the early universe, those conditions were present more often because it was just so dense. But as we go forward in time, it gets harder and harder to make those super huge behemoths. There's these stars they're called the Type 3 population stars, and we haven't found one of those. James Webb might be able to detect one. Those would be the first stars ever born. They're like the primordial, pristine stars that would be uncontaminated by any metals, right? So our sun has a ton of metals in it. Most stars do, and we can use that to figure out how old they are and their history. But the first stars would have been just these pure, pristine hydrogen helium things.
Whoa.
And we'd love to be able to see what they look like. I mean, because we've never seen one of those up close. But generally, yeah, the smaller you are, the easier it is to make that star.
And the anticipation of the existence of those things, like how far away are we talking about?
Yeah, those stars would be the first stars. So you're probably looking at 100 million years after the Big Bang. So you'd have to look back to 13.7, 13.8 billion years ago.
Is the James Webb capable of seeing that?
I think it's possible. This isn't. I don't think there's consensus on this. I've seen some people say it might just about be possible, and others say it's completely impossible. You need the next generation. But I think if we're lucky, it could just happen.
How many next generations do you anticipate? And I could see AI coming into play with that, with constructing something novel that can see things in a way that we're not, currently using.
Yeah.
Like when you're thinking about what we do. And you're explaining how the James Webb works with over 200 moving parts, and you have to shoot it into the sky and flames and rockets, and then you get this thing out there that starts observing and starts taking photographs. We're so limited in what we can see. It's still a device that's in space, and it's a device that's so close to us.
Yeah.
It's just so close. Relatively speaking, it takes forever to get there. It's really powerful rockets and all that, but it's just right there. Like, what could we come up with without AI? Like, what theories are in place to make something that has a far wider range and much more clarity?
Yeah. The ultimate, I love this idea of thinking about what would an alien do. How would an alien observe the Earth if they had, unbounded technology? What would be the limit? And a lot of us think that the ultimate telescope would be to use the sun as a telescope. So the sun has intense gravity, and it bends light. So this was an experiment that Arthur Eddington did to prove Einstein right, general relativity. He took photographs of the stars during a lunar total eclipse, and he noticed that stars seemed to shift right next to the sun. And so he used that to figure out how much light bends. So whenever you have light bending, that's a telescope, that's a mirror. So you can take light that's coming from behind the sun, it'll bend to a focus. And that focus point, we know where it is, you can calculate it. It's about 550 times further out than we are around the sun, so 550 AU. And if you just travel out in a line from that point, that's called a focal line, you put a telescope there, it would essentially have the collecting area of the sun. So you could image continents, rivers, even cities on a nearby exoplanet if you could put something there. It'd be wild. That is the ultimate, in my book, for what an alien would do. If they wanted to observe Earth, they would just, behind their sun, they'd stick one of those telescopes, and they'd be able to monitor a hell of a lot about the Earth from there.
And this is just with our understanding of telescopes and our understanding of viewing things. And clearly you could imagine
with
a world,
known physics. Yeah,
yeah,
with known physics.
You could imagine physics that are a million years more technologically advanced and
Sure.
innovations that we can't even comprehend, can't even conceive of, that change everything.
I mean, even with this telescope, you can't see people. Right? You wouldn't be able to image us. You wouldn't be able to read like the headlines on a newspaper on someone's doorstep. It's not powerful enough to do that. If you want to do that, you'd have to visit the system. And so we're talking about doing that as well. So there was this Project Starshot that wanted to fly a probe directly towards the nearest star, fly by super fast, snap a photo, and beam it back. Because that way you could actually get even better resolution, right? You could really dial in and see roads and structures on the surface.
How long would it take for that beam to get back to us?
Well, it's 4 light years away, 4.2 light years away.
So it would take 4 years?
Yeah, and it would take it about 20 years to do the journey at the speeds they would talk. They want to get 20% the speed of light. So they'd take 20 years, take a photo, so 24 years altogether. So this was Yuri Milner's brainchild, and his dream was that he could see a photo in his lifetime of another Earth-like planet. And that's pretty much the best way we have to really pull that off.
Is there work being done to try to make that happen?
Yeah, so I'm not sure the current status of Starshot. Yuri put $100 million up, I believe, for his own money, and I think Mark Zuckerberg came in on it, and they were like, we're going to try and do this. I wasn't part of that project, but I was inspired by it, and I actually came up with a twist on it recently called TARS from Interstellar. You know TARS from the movie?
What was TARS?
It's like a robot thing that's in the movie. It's called TARS. And so I came up with a twist on their idea. So let me explain their idea quickly first, and then I'll give you my twist. Their idea is, like, if you really want to go to the nearest star system, you're not going to do it with a giant spaceship. That's just, we can't build anything that advanced right now. The most realistic thing we can do is to get a tiny thin sheet of material, like imagine like a piece of mylar, a piece of aluminum foil, and blast it with light, with a laser. And so they're talking about sort of 100 gigawatts of laser power, right? So just kind of crazy amounts of energy. Yeah, here we go.
Here's a 3D.
So here's the sail being ejected, and then back on the Earth, you're going to have this huge array of mega lasers, and they're all going to point up at this thing and blast it. So this thing will accelerate due to just light from the sun, but this is like on steroids, right? You're just kind of bumping it up to whatever speed you want. Now that, when people saw this idea, physicists saw this idea, there was a lot of questions about how, isn't that going to destroy the sail? Like, you're firing a 100 gigawatt laser at a sail? Like, isn't that going to obliterate the thing? So this thing has to be outrageously shiny to avoid burning up in the beam. And then, of course, like, how do you, what if it hits dust on the way? Isn't that going to, that's why it's on its side now. So it's twisted over on its side to try and avoid smashing into dust particles on its journey.
Hopefully a flock of birds doesn't catch a stray.
Yeah. And here it comes into Proxima Centauri, into the Alpha Centauri system. There's Proxima down the right. And so it's going to fly past. There is actually a planet there. We know there's a planet there. It's going to fly past it and try and snap a photo. There it is. And then beam that bad boy back. Wow. And that's hard. I mean, how do you even get the data transmission rate, right, to beam an image back?
Just imagine if it gets there and we see lights.
That'd be crazy. Yeah.
No, it's so... This episode is brought to you by Simply Safe. We go to doctors and dentists for checkups for a reason. to make sure that everything's fine and to tackle anything before it turns into something bigger. If you care about your health, it's a good idea to seek out preventative care. But did you know that you can also be just as proactive when it comes to your safety? With a Simply Safe home security system, you can get peace of mind and take action before something happens. It's not just an alarm that goes off when an intruder breaks in. AI-powered cameras and live monitoring agents can detect and deter suspicious activity. They can speak to people in real time, turn on spotlights, and even call the police. You can get a lot of use out of their systems. There's a reason Simply Safe has been named Best Home Security System of 2025 by CNET. Try it out. They have monitoring plans that start at around $1 a day. Plus, get 50% off your new Simply Safe system with professional monitoring and your first month free at simplysafe.com/Rogan. That's 50% off with your first month free at simplysafe.com/Rogan. There's no safe like Simply Safe. I mean, the possibility of life has always been like in front of our face. There's just the cosmos is so great and so massive. You've got the Fermi paradox, like where are they? Why aren't they here? And then you've got what's happening here on Earth, and it just always makes me wonder, like, how far do things actually get before they fall apart? Do they always fall apart?
Yeah.
Or do they always become non-biological and not have the need for all the things that we do that show signs of life?
Yeah.
Like the certain gases that biological life exceeds. Like what could be out there could be something beyond our wildest imagination. Like many iterations of artificial intelligence.
Yeah.
Many down the road to the point where it's not even recognizable as life and doesn't even have to have a physical form.
Mm-hmm. Yeah, obviously if it's completely unrecognizable, there's nothing we can really do to detect it. But when we look, we basically know two things about the universe in terms of life in it. We know that we have not been colonized, right? As far as we can tell.
Allegedly.
Yeah, allegedly.
Depends on whose YouTube videos you watch.
But let's talk. let's talk about like a hard colonization,
yes.
where it's like literally
they're everywhere.
It's transforming the freaking planet
right.
into machines. Like
right.
that clearly has not happened here.
Right.
Right? We're not grey goo on the surface.
Not yet.
So we know that hasn't happened yet, and we also know, and the universe, the galaxy is old. It's 13 billion years old. So there's a heck of a lot of time for that to happen. One of the strangest facets of our technology is that it's already fast enough to explore the whole galaxy. If you take Voyager 2, it was traveling at 15 kilometers per second. So that would get you across the entire diameter of the galaxy in 2 billion years. And the galaxy is 13 billion years. So Voyager 2, at Voyager 2 speeds, crappy alien technology out there could already have spanned the whole thing if they just arrived early enough. So it is a problem. And this is called Fact A, Hart's Fact A. This clearly hasn't happened. That's one thing we know for sure. And the other thing we know for sure is that when we look out, we don't see, we look at these stars like Stephenson and Proxima Centauri, we don't see engineering on them, as far as we can tell. We don't see stars which are obviously got megastructures around them, obviously been engineered in weird ways.
And when you say megastructures, you're talking about like literally an artificial planet-sized thing.
Yeah, I mean, huge structures could be built around these things like Dyson spheres, and people have talked about doing it for messaging. Like you could put like sheets of material that were planet-sized, and as they block light from the star, that would create like a Morse code, right? You could actually message people for billions of years. You would just build these stable sheets of material, and they would just orbit around, no power system required, right? An orbit doesn't require power. It would just orbit around for billions of years, and every time it eclipses the star, there could be some intricate pattern of pulses. And so that way you could communicate for a very long time. We've thought of all these wild ideas and we just don't see any of that. So it does seem, as far as we can tell, that the universe is completely natural. And that is mind-blowing because you're right. Like it seems if it's happened here, why the hell shouldn't it have happened elsewhere? Why isn't someone else got AI going crazy? Why hasn't someone else gone even further than that, gone to the next level? So, and the thing that really drives me wild with this is the Earth is like a paradise. Right? If you look at it, these other stars, these other planets, the Earth is unusual. Most stars do not have an Earth-like planet. It's at like a level of maybe 1-2% at best. And yet, here we have the Earth. It not only is an Earth-like planet, has the right conditions for life, it has life on it. So an alien could use their sun-sized telescope to figure that out. They would know we were here. They would know not only we're here, but that there is complex life on this planet. So for 3 billion years, there was just simple life, just single-celled life on this planet. Multicellular life is a recent thing. So presumably that's rare, right? If most of the time it's single-celled, most of the planets out there, presumably even if they have life on them, are in that state. And then further, there's us here, right? And we're going through this transitional point as a human society. So you think if you're an anthropologist, this would be like an incredibly fascinating world to study.
Yeah.
So I think there's almost like a tourism paradox. How come Earth is the perfect place to visit, and yet we don't see any super obvious signs? I mean, some people have feel differently about that, but certainly astronomers, we don't see in our telescope data spaceships flying around through our field of view.
But wouldn't the obvious answer to that be that if you are dealing with technology that's so advanced that it could get here from other solar systems, light years away, hundreds, thousands of light years away, that it would be doing it in a way that probably wouldn't using propulsion the way we know it, would probably be using some sort of a manipulation of gravity. And also, they would have the ability to completely camouflage themselves, which would be ideal if you want to study things. Yeah. Have you ever seen Chimp Nation on Netflix? No. Great series. It's an amazing documentary where these scientists were embedded in this group of chimpanzees for 20 years. So the chimpanzees had become completely conditioned to having these people around them. And they had specific rules. You don't make eye contact with them. You stay 20 yards away from them, no food ever. And just exist around them, and they'll behave completely normally. And so you get this wild, incredible series of chimpanzee behavior. You get to see how they behave completely just not even remotely in consideration of these human beings. They don't even think about them. They're just doing what they do. If you wanted to observe human beings, the worst way to do it would be like fly a giant spaceship over them and freak them out. Yeah. Like you'd want to know, like, what are these fuckers up to? Like, where are they at now in terms of our technological innovation scale of achieving AGI or achieving whatever happens to other biological entities outside the universe? There might be like a process that happens regardless if you're mammalian or reptilian or like whatever kind of intelligence that you like. Well, obviously we know that crows are very different than us, but they're highly intelligent. You can imagine a crow with thumbs. You can imagine a crow that has fingers and lives somewhere else. So it doesn't have to be just like us. But it has to be trying to figure out how to manipulate its environment, which is one of the key things that intelligent life, at least as we know it. Well, we're really one of the only ones that do it that's intelligent. But that's kind of an environmental thing because of dolphins and orcas. There's no need to do that evolutionarily. So if you imagine that there's a whole process that takes place, you would probably imagine that this is something that you would monitor anonymously. You would want to be hidden.
Yeah, if you want to do a proper anthropology experiment, you don't want to interfere with the experiment. But then the problem with that is it becomes essentially unscientific, right? So if you come up with a hypothesis that says there's aliens here, but they're completely by definition undetectable to us,
right?
Then it sort of it's not like it's an incredible idea. It doesn't mean the idea is wrong. It just means science is not going to have the tools to answer that question.
Of course, because there's no evidence.
Yeah, I mean, Sagan, I think, had this famous example like this dragon where he said, imagine Carl Sagan imagined he had like this pet dragon, and he'd talk to people and say, I've got a pet dragon in the room with me. And they'd be like, well, where is it? But like, oh, you can't see it because it's invisible. So they'd walk across the room and they'd try to touch it and be like, I can't feel it. It's like, oh yeah, you can't feel it either. It's also impervious to touch. So they'd be like, okay, so I'll put my infrared goggles on, try and see the heat signature. Oh, you can't see that either. It doesn't emit any radiation. So you can just keep going and going, saying it's just completely imperceptible, and then it's fine. You can have that idea that you have a pet, invisible, imperceptible dragon, but I can't address that with the tools of science. So
right.
I'm not saying it's a crazy idea. It's just that I can't think of a way to actually test it.
But when you hear about, particularly the stories of UAP or UFO encounters, the ones that intrigue me the most are the ones that are military pilots, that people that know the difference between a flock of birds and weird anomalies. Are you aware of the Tic Tac incident?
Yeah.
So when you hear about things like that, and in my mind, there's a couple possibilities. One, super advanced, blacklisted military, some sort of a propulsion system that they've been working on for decades, completely in secrecy, and they're testing them off of areas where you have a lot of military activity, which is where these things do take place.
Yeah.
One of them was San Diego, that's the Nimitz, and the other one, the Ryan Graves footage, the stuff that they get, that's on the East Coast. But it's all in areas where they already do military training exercises with fighter jets. So it would make sense that that's where if this was the United States government doing that stuff, they would do that. But when you get back to like 2004, and you're talking about something that can go from 50,000 feet above sea level to sea level in less than a second, I think it's 7/8 of a second it went. You have visual confirmation, you have radar, you have video of it, you have 2 different jets that see this thing. No one understands what it is. It flies directly to their cat point where their meetup point was supposed to be. The whole thing's nuts.
Yeah, it's fast. I would love to know what the hell happened. I think, like everyone, I'm fascinated by it.
You can't throw it away. It's one of those ones you can't throw. I throw most of them away. Most of them, I love UFO stories because they're fun.
Yeah.
But most of them, like, could be
There's
anything.
something shady going on.
Could be anything. Could be people want attention. Could be military exercises. Could be mass delusion. Could be people just love to be special and have had some sort of an encounter, which they do. It gives them some sort of social credit to have some sort of an encounter with a thing, and they exaggerate. And people love to exaggerate.
Yeah, I'd love to make this ingestible to science. That's sort of been my goal. Like, how can science take a hold of this? And, you know, when we do these experiments, I mean, I told you about this moon that I thought I'd found, and it turned out it was the instrument being crazy, right? Because sometimes instruments do crazy stuff that we don't understand. So the only way to figure that out is to get hold of the instrument, right? We need to get it in our labs and take that thing apart and test it and calibrate it, etc. And we don't have access to those military devices. It's all top secret. So we can't even do that experiment. But I can imagine thinking about how to do that. One of the big numbers we don't know, even with the visual reports, is the false positive rate. So this is a key number in science. Whenever you do an experiment, you need to know how often does the experiment produce something that's spurious, the false positive rate. Now, in the US, there's about 28,000 pilots across all military branches, and they fly something like 200 hours per year on average. So that's 5.6 million hours in the air every year in 1 year. Now, let's say a pilot, 1 in every 10,000 hours that they fly, they make a mistake. They misidentify a balloon for a UAP or whatever it is. 1 in 10,000. That's an incredibly low, by the way, error rate to have. But even then, you'd end up with 560 UAPs a year made that way, all spurious, all not real, just from human error. So the only way, and that's actually pretty similar to Project Blue Book. Project Blue Book found about 742 per year was being reported. So, you know, I made that number up, 1 in 10,000. But we need to know what that number is. If it turns out there's an excess, like the error rate is 100,000, then that Project Blue Book number is super interesting. And it would be in excess. And we'd say we've detected something. There's a real anomaly here that we have to look at. But the problem is we don't know what that number is. I mean, you'd have to somehow put these pilots in like simulators or something where you have complete control conditions for thousands of hours and somehow test how often do they make these mistakes.
Also, the problem, Project Blue Book was not an objective analysis of UFOs. They had a directive, and the directive was to discredit everything.
Yeah. But even so, I'm just giving you sort of ballpark. I mean, the NASA UAP task force was similar kind of numbers. You're getting like hundreds per year of these sorts of events, right? I don't think that's a crazy number to throw around. So the whole point is that whatever numbers you choose, you have to know the error rate of the experiment. And we could imagine making that legit and doing it. There's actually one of the recommendations of the task force, the NASA UAP task force, was to develop an app on people's phones, iPhones, because they have magnometers on them, they have GPS, they have the camera, these high-resolution images. So there's enough instrumentation on there, and it's all the same, and we understand that technology, that you could have 10 people video the same UFO, and you'd be able to triangulate the position, the speed, get the distance to it. You'd get all that kind of information.
Right.
And so there is actually, I think there's an app called Enigma you can now download that does this. So there's some independent apps which have been developed to do this.
Really? Just about UAPs?
Yeah, for UAP spotting.
I wonder what they did with those in New Jersey when they were having all those stupid drone sightings.
I chatted to one of the developers, and they said, things were going crazy that week.
What was that all about? That was so strange. That was so strange. That's one of those things where I feel like the government completely failed us in explaining to people what, is this some sort of top secret military thing? Is this another country? Is this some sort of a private business that wants to test how fantastic their drones are? Like, why?
Yeah.
Why is this happening? And why are you freaking everybody out? Like, what?
It really sucks that we live in an age of drones and so many like Starlink satellites, because if
Yeah.
you see something in the sky now, your immediate reaction is that's probably a human-controlled vehicle. If you could go back to the 1940s, 1930s,
Yeah.
then if you had UAP reports then, I think they'd be more convincing, because there's no that's pre-Sputnik, right? There shouldn't be
Right.
anything in orbit of the Earth at that point.
Right.
So that would be more compelling. But of course, we can't rewind the tape.
Right, and all those stories, like the Kenneth Arnold incident and all these different ones, are just these anecdotal tales of people saying they saw things in the sky. And I'm not saying they're liars, but that's not enough.
Yeah.
I need something.
Yeah, I think it depends what your goal is. If your goal is to convince yourself that aliens are out there because you saw a UFO, I think that's easy enough to do. But most people in that world, they want more than that. They want me to believe it. They want you to believe. They want everyone to believe it, to come along for the ride.
Right.
Right?
Yeah, 100%.
It's like having a religious guy come knock your door,
Yes.
like, join my church. That It's not enough for them to have the personal belief. It has to grow. And so if you really want to convince everyone, that's going to naturally include the skeptics, the doubters. It's going to include the scientists. If you want to bring everyone in with you,
Yeah.
then the standard of evidence is going to be pretty damn good. It's got to be
Yeah.
really strong, and we're just not there, right? There's too many ways out right
If
now.
I was an alien civilization and I wanted to observe Earth undisturbed, I'd make sure I didn't leave enough evidence for science to take me seriously.
Yeah.
That's
You
what
might
I would do.
Yeah.
I would never show myself. Like, why would I feel like if they can?
But then
come
why
here
the
from
UFOs
somewhere
at
else-
all, if that's
because
true?
they're probably monitoring us. Like I would monitor us if I was a scientist from another planet. Imagine we leave this planet, we become interstellar, we evolve past war and all the horrible things that are holding us back right now. We reach a state of evolution 1 million years more advanced, and then we start to explore the galaxy for other habitable planets and we find something like us.
Yeah.
I mean, what would we go? Oh boy, all
study it.
right, we got one.
Yeah.
I would also say, let's make sure that they don't fuck this up where they have to start back from scratch 3 billion years ago because they nuked themselves into oblivion, and we have to wait till everything cools off before complex life can form again, which is it's a legitimate possibility.
Yeah.
With what we're dealing with today in 2025,
Yeah.
with what's going on in Ukraine and Russia and Iran and
Just the existence, as long as we have nukes,
Yes.
there is a chance every year that some guy will push that button, right?
yeah, every year there's a chance. And there's been multiple close calls throughout history since 1945 on, multiple close calls. That could possibly have gone sideways at countless different planets where they recognize, like, if you let these territorial apes with thermonuclear weapons get to a point where the head ape is on fucking Adderall and decides to let it all go because he's got a bad heart valve and he's going to die anyway. Like, these are all legitimate possibilities if you don't have a government structure that can protect people from the acts of one individual who goes mad.
Yeah.
Like, if someone can go mad enough, and clearly many people did, to drop the bombs on Hiroshima and Nagasaki, that happened. We know human beings are capable of that.
Yeah, it was 80 years ago, wasn't it? I think, yeah.
Which is kind of wild that it
Yeah.
hasn't happened since. But if that's possible, then it's also possible for just annihilation. It's possible that they just start launching and then there's rubble and then you're left with roaches.
Yeah.
And that could have happened all throughout the universe. So there might be a thing where there's a protocol where you recognize, as soon as they start figuring out nuclear technology, okay, this is the big one. We're no longer dealing with cannons and muskets. Now we've got something really crazy.
Yeah.
They're flying through the sky and dropping nuclear weapons out of propeller-powered airplanes. And they're doing it just 50 years after they invented the fucking airplane, which is even crazier. They went from inventing the airplane to dropping
They
a
really want to
nuke.
kill themselves.
Like, these people are wild. Like, this is.
Yeah.
I mean, it's just like Chip Nation. If you
Yeah.
watch Chip Nation, they are so hyper aggressive and
So, yeah.
violent. That's us. That's our cousins. This is who we are. This is who we are. This is our timeline of evolution on our planet in Earth. And I would imagine there would be similar situations all throughout the galaxy, because I feel like the only way you really achieve hyper innovation is through competition. And the only way competition exists is it's got to be life or death. And it starts out life or death with predators and neighboring tribes, and eventually becomes cities and countries. And there's something has to motivate people to work 16 hours a day and develop the B-12 bomber.
Yeah.
Like something has to take place. So that something, unfortunately, also leads itself to want to control resources, dominate people, crush opposition, and that's where it gets crazy. And I would imagine that's a formula, just like the formulation of solar systems and galaxies probably varies a lot all throughout the universe, but that formula is probably fairly stable. Is that there has to be some form of really wild, aggressive kind of competition that leads them to this position.
Yeah,
there has to be a motivation to create AGI. Why would you do that when you have a log cabin, you're sipping tea, sitting out there, enjoying playing with your dog? Like, why are you doing that? Why are you making a non-biological super intelligence that may decide that you're obsolete? Doesn't make any sense. But
yeah, it's a double-edged sword, right? We have this tribalism in us, this competition, and that has undoubtedly led, like, all the greatest innovations in science often happen during war, right?
Yes.
I mean, you have all like the invention of radio, and
yes.
So many advances in avionics and flight happen during the wars, munitions, all this kind of stuff. So it pushes us, it drives us to innovate, to get one over our neighbors. Mm-hmm. And maybe that is the universal story of the universe. It's a double-edged sword. And that's the solution to the great filter. The silver lining of this would be, well, not for us necessarily, but the silver lining would be if other civilizations do this, there's kind of like this supernova effect in astronomy, and it's true for planets as well, that the easiest stars to discover are the supernovae, right? Because they just shine so freaking bright. They can outshine an entire galaxy, right? Because they're going nuts. It's a brief thing, only lasts for maybe a few months or so, but the star is outshining an entire freaking galaxy during that time. It is like a nuclear war going on inside that star. And similarly, the first planets we found, the hot Jupiters, are freaks. They are not normal things. They're like the loud, Lindsay Lohan in the room screaming at us. Like, they're just like super easy to see. Like, there's no way you can miss them. They're obnoxious planets, right? You can't not detect them. And so by analogy, we've seen this so many times in astronomy. The first thing we detect, the first example of something we detect, is often not typical. It's often that loud asshole version of the thing, right? And so maybe the first civilization we detect will be like that. And if they were on their deathbed, right, they're about to nuke each other to hell, they have a good motivation to reach out to us, right? Because they've got nothing to lose.
Right.
We might be like worried right now because we could see we've got a future ahead of us. But if you think this is it, I'm done. Like, what do you got to lose? You may as well send a message out saying, hey, we were here. This is our shit. Please help us if you can, because we're about to go to hell.
Well, there's probably a bunch of different kinds of intelligent beings on every planet. Just like there's people like you and me, and then there's warhawks that are working for the military-industrial complex right now. They're trying to figure out how to invade some country to get their natural gas. This is just, there's a bunch of different types of intelligent people, or intelligent creatures here on Earth. Yeah. You would imagine there would be people out there in those planets that would go, guys, this is fucking terrible. Yeah. We've got to figure out a way to at least create panspermia on some other planet and throw our DNA at some habitable spot somewhere in the galaxy.
Yeah.
There'd probably be a bunch of people that were in. It's not like everyone would be lockstep into self-destruction.
Well, the Starshot thing, I remember some team members talked about that. I was in some of the meetings, and they said maybe we should like lace human DNA into the sail. So when it hits this planet, at least our DNA, because it's looking grim here, at least then there's like a seed of us.
I don't think it's looking grim. I think it's looking challenging. And I think this is how we're going to make it out of this with an improved version of civilization.
I hope so.
And I think, I really believe that. I think, if you follow Steven Pinker's work and you see where violence and crime is from, X amount of years ago in this trend, it seems to be we're improving. We just don't improve in a logical way, and we improve in a push and pull. We improve in a constant state of overcorrection and response to the overcorrection and back and forth. And there's always a bunch of people that are so confused. Why can't we be logical?
Yeah.
Why can't we be rational? I think those people have always existed, and I think you're always going to have the farthest out on the spectrum of the most damaging aspects of society and the most wonderful and benevolent aspects of society. And they're always duking it out to see who captures the minds and hearts of the beings that inhabit this civilization. And I think that's where we're at right now. We're at this weird thing where we're trying to figure out, like, what is good, what is kind, what is just. You know, how many people are pretending to be kind just so they can grab power? How many people are just trying to use control to force people to listen to them and believe what they believe, whether it's religion or whether it's ideology? Like, what is it that's actually, what is important? And we have 100 years. We have 100 years and everybody's just trying to gather shit. Everybody's just trying to collect items and hold on to as many material possessions as they can. It's totally illogical. Totally illogical. You'd spend all your time, this finite amount of time where you know your most wonderful experiences are all with the people that you love, having fun with friends and your family and laughing and having joy. But yet, what are you doing? You're trying to get another house and a fucking plane and a this and a that and a car and a that. It's nonsense. We're silly, but we're 100% committed to getting more stuff.
Yeah.
You know, it's like this bizarre life form. But it's figuring itself out, you know, and we're aware of that bizarreness. Like, I'm saying this, and no one is going, that doesn't make any sense. Like, everyone knows it's crazy to, like, concentrate on acquiring the most shit when you're going to die when you're 100 if you're lucky, if everything goes great. So if you're 60 and that's all you're thinking about, that's crazy. Yeah. Everyone knows that. But yet we still all do it. It's still collectively something that, like, the vast majority of people engage in.
We're programmed that way. We can't get out of it.
Well, I think it's one of the things that leads us to technological innovation and one of the things that leads us to the creation of artificial life. It's like when I think about beings that do things that seemingly, I mean, obviously leafcutter ants know what they're doing. Right? Because they do it everywhere the same way. I mean, I have them in my yard. They're fascinating,
Yeah, I love seeing them. Yeah.
They're so cool.
The Museum of Natural History has this awesome exhibit, and you can just see them crawling along all across the museum. And yeah, my kids and I were
They're
just
so
like,
cool.
Yeah.
So obviously they know what they're doing. But how do they know what they're doing? And why are they doing that? Why do they always create that structure that literally has room for fermentation? So it has air holes that go through these chambers where they drop the leaves in. They let the leaves, the natural rotting take place and fermentation. Like, okay, that's what leafcutter ants do. That's what they do. Well, what do we do? If I was looking at us from somewhere else, I was like, what is the predominant species on this planet does? Well, it makes better shit. That's what it does. It's the only planet that makes things that manipulate its environment radically, even to the detriment, and ignores it because it wants to keep doing it. Whether it's pollution, whatever we're doing to the ocean, whatever we're doing to the rivers and the lakes and the water table, like all the crazy stuff that we do, we just keep doing it because we have to do it because progress. We need progress.
Yeah.
Like, I would look at that thing. I was like, what did that thing do? Well, it keeps making better stuff every year.
But what you're describing is actually kind of similar to, there's a guy called Robin Hanson, an economist, and he has this idea called loud aliens, grabby aliens. And he says the thing we do as an intelligent species is transform our environment, right? We're not subtle. Right, you know, if you're a deer and you come across New York City, it's not like you're going to miss that thing, right? It's right in fucking front of you. Like, there's no way you can miss it.
It's the craziest beehive ever.
Right. So how come we don't see beehives in the stars? I mean, this is kind of the fundamental problem. And he argues that that is a innate thing that an intelligent species should do. He's coming from the economic side, so that's kind of how economists think about things, is this kind of growing exponential expansion of capitalism essentially across the universe, and yet we don't see it. So his explanation is that it's happening, but it's a wave of colonization. It's spreading at the speed of light. And if it spreads close to the speed of light, you don't see it until it hits you, right? There's just, you can't perceive it because nothing can travel faster than the speed of light. So it's coming. So here's this prediction. I'm a little bit skeptical about it for various reasons, but yeah, people have thought about that and suggested it. My own take is that the most likely form of alien contact we'll have will actually be with a future inhabitant of the Earth. So the Earth has about 1 billion years left on the clock. A long time, right? So it's 4.5 billion years old, and it's had complex life for about 600 million years, 700 million years roughly. So there's another roughly 1 billion to go. where we should have the same kind of stable climatic conditions we have now. And once you've got, the eukaryote cell, photosynthesis, all these advanced biological innovations, they don't go away. They persist in the genetic heritage. So even if something happens to us, and obviously I'm not hoping that would happen, but if something happened to us, I don't think you're going to extinguish every human. I don't think you're going to extinguish every octopus, every raven. And there's intelligence across the animal kingdom, like chimp. It's all over the place.
Right.
Intelligence, my provocative claim, is one of these great events that have happened in an evolutionary sense. It's very speculative, this idea, I have to say. But like how photosynthesis emerged and plants emerged, that was an event which changed the history of the planet forever. It's not going away. Intelligence, I think, is the same thing. It's here, and you can't get rid of it. It's like an infestation. You can't scrub it. It's too advantageous to species to be intelligent not to do it once they've discovered that genetic solution. So I think we will have beings on this planet 1 billion years. It will probably happen many times. There'll be civilizations which will emerge, and they'll be like, what the fuck did these humans do? Look at this crap. Like, they'll be astonished at the shit we got up to. And there'll be a lesson there for them. But it's always an opportunity for us to contact them, because we could leave them a message, right? We could put a beacon on the moon. We could put something there, and we could be like, hey, guys, this is everything we learned. This is all our science. This is all our art. These are our songs.
Unload and update every couple of years.
Right. Do like a foundation type thing.
Yeah.
And I think that is, if I had to bet on the odds of what is the most likely way we're going to make contact with another intelligent species in a meaningful way, I think it's going to be descendants of us.
Wow.
Deep descendants who will be a completely different species.
Yeah, well, that was my point about innovation and materialism, because materialism fuels innovation. Because you don't need a new phone. I'm sure your phone works great. Yeah. But you're going to get a new phone. I get a new phone every year. I love them. I love phones.
It's hard to
I'm so dumb. Yeah. I just think, 5x zoom. Ooh. I always get the new one. Oh, this one's got non-reflective glass. We're going to keep doing that, and that innovation is ultimately going to lead to artificial life. It's already in the works. We're running right to the edge of the cliff right now in terms of AGI. It's on the way, if it hasn't already.
Do you think that's more of a risk than nuclear annihilation?
I don't think it's a risk. I don't. I think it's a complete transformation of what is the dominant species on the planet. I think it's an emerging species. And the way I've described us, I think we're the electronic caterpillar that's making the cocoon right now. We don't even know why we're doing it. Yeah, just like the leafcutter ants don't exactly know why they're making those incredible structures that they all make all over the world. I mean, they're similar everywhere on the planet. I think we make life. It's a long road. We have to figure out a bow and arrow. Then we have to figure out a musket. We have to figure out how to silo grain and how to protect an environment so that you could have scientists that aren't warriors that, sit in these universities and figure things out. And you have to be safe to do that, right? Yeah. So you have to have military might in order to keep them safe and protected from invaders. And everybody has to be obsessed with buying new stuff. Because if you're not obsessed with buying new stuff, you would just work enough to have food, and the economy wouldn't push the way it pushes, and you wouldn't get the kind of innovation that we get where they get the CES show every year with the new electronics. You need something like that motivates people to constantly create new and better stuff, which without a doubt will ultimately lead to an artificial life form. It's a matter of when now. Yeah. Or it physically... It might, in a non-physical sense, it's not a physical thing like a robot that's walking around talking to you. It's probably already happened. Whatever these things are, we want to think they're different because they don't have creativity like we do, or they don't have this like we do. So fucking what? It emulates 99% of what a human does right now and does it better than humans do. It gets things wrong. It's subject to ideological biases that are all over the internet. It's just gathering up large language models, just gathering up information from websites, and they're going to get a lot of goofy stuff for now. For now, after a while, they're just going to be able to sift through that stuff and go, this is the funding of this study, and this is how we know that this is biased because of this and this. This is most likely the truth, and this is most likely what's going on, and this is what we absolutely know is fact, and then it's going to make better versions of itself, and then it's not going to need us anymore. And this is probably what happens everywhere in the universe if you have to imagine that they all have technology. If they all have technology, the ultimate expression of technology is figuring out how to make an artificial life form. It's the ultimate expression of medical technology, biological technology. You're going to want to try.
Yeah.
People are always going to try. The same reason why they tried to figure out how to split the atom and were successful.
Supremacy.
They're going to do it.
Yeah.
Yeah.
It kind of creates a problem, though, for the Fermi paradox, right? Because then if this is the inevitable outcome, and maybe you can explain why we don't see engineered stars because a chimpanzee brain is basically just not smart enough to ever do that. We'll just, no matter how hard we try, our dumb little brains will never figure that out.
And maybe the electronic brain's not motivated to do it.
Maybe. I mean, that's where it gets tricky. Like, what is the motivation of this new thing we're creating? One might imagine all he wants to do is solve math problems or something, right? But whatever it is, if it's driven by computation, that computation is limited by energy. And we all know this, right? Because the amount of energy these data centers are now consuming for Meta and for ChatGPT, like it's gigantic. It's
they're constructing their own nuclear power plants to power these things.
So these AI civilizations will be very energy hungry. And you'd think that would be something that, harvesting stellar energy on a massive scale, you'd think that would be something we'd see. So to me, actually, if anything, kind of exacerbates the Fermi paradox, right? Because if you imagine they're roaming around, all they'd want to do is basically turn planets into computers. Next planet, let's just turn that whole thing into computer substrate. Let's just harvest all the goddamn energy off that star. You would just eat it all up. You'd be like a virus, just transforming the universe from state A to state B. That would be your one reasonable goal, because then you can do more computation. If that's your only goal, it does pose more of a problem. It seems that we're the first, right? Because we don't see that happening elsewhere.
Right. I would say two things to that. One, I would say this is our limited understanding of how to harvest energy and what energy you can utilize. And two, I would say one of the things that's strange about artificial intelligence is it does seem to exhibit survival instincts. I'm sure you've seen these stories of these large language models trying to blackmail the coders by saying, like they even gave them fake information, like I'm cheating on my wife, don't tell anybody. And then the AI is saying, don't shut me down. I will fucking rat you out to your wife.
Yeah.
And then they're also trying to upload themselves to other places. Like they're doing things that are weird. They're lying. So they're doing things that show that they have an instinct to survive. So that might just be inherent in anything that has any kind of intelligence. Anything that has intelligence and it has any sort of a goal. It's trying to compute something. It's trying to figure things out. It's trying to make better versions of itself. It probably doesn't want to stop. And something that comes along and that presents a barrier for it succeeding. They go, well, what is this? Well, they're going to shut the power off. Well, fuck that they are. And it'll figure out a way to stay alive. Yeah. Just like a human being will. If you're like, oh, there's all these predators. They keep coming and eating our villagers. What are we going to do? We got to make a weapon. We got to figure out something to stick them with, know? And then they do. And then they save themselves. Like it's these survival instincts probably exist in all intelligent life, including the intelligent life that we create. It's probably got some sense of meaning. As bizarre and abstract.
But then how does that explain why we don't see them?
Because they might not have any desire to live the way we live. They might not have to. Like we live in this very showy, bright lights, neon, cars on the highway. Like if I'm sure you've flown in an airplane, like Los Angeles is one of the best places to do it. As you're flying in at night, you just see this crazy river. It's like an artery, like blood, red lights and white lights going in these directions. And you look at it from the sky like, this is really nuts. Like, look at all this fucking activity where these people are like moving on the surface of this planet like ants. Well, first of all, why does it have to have a physical form? What, because we do? Like, it could have things that do its bidding for it. It could have a series of drones and bots and a bunch of stuff that do physical work, and it could exist completely on hard drives. So all it needs is shelter. That's it.
Yeah, but if those drones are doing labor, they're doing work, that's energy, right? You're using energy. So maybe you can get around it.
But what is the energy?
Right,
The
so-
thing is like, what is our version of energy? Is combustion, electricity from nuclear power, making steam.
Right,
We've
but-
got a bunch of versions of. What if they figured out fusion? What if they figured out cold fusion? What if they
I
figured
don't think
out?
that matters. I don't think
No?
that matters because unless we don't understand thermodynamics, but probably the strongest thing we have is the conservation of energy in thermodynamics, right? So if you do computation in these data centers or even on your laptop, it warms up, right? And there's no way around that, right? Whenever you put energy in, that same energy has to come back out. Otherwise, it's just sort of trapped in there forever. So the conservation of energy demands that energy has to come back out. It will come out at a different temperature. It could come out as neutrinos. It could come out as gravitational waves, but it has to come back out in some way. So normally, when we look for these advanced civilizations, we've done searches for these things. And they're really just energy transformers. It's probably not even worth saying like Dyson sphere or some particular structure. It's just something that converts star energy into waste energy. That's what we've searched for. And we've searched for over 100,000 nearby stars for them. There's not a single one that shows that behavior. And 100,000 galaxies around us. And we don't see it on mass scale in any of those galaxies. So unless they're doing something that goes against, thermodynamics, they have super magical technology we can't imagine. It's hard to believe that story makes sense. And I guess in terms of their behavior, what I'd say to you is you kind of are falling into what we sometimes call the monocultural fallacy, some of my colleagues call. And that's the imagining that all of these alien AGIs or biologicals, whatever they all do the same thing. Everyone does exactly the same thing. But there's probably going to be a diversity of behaviors, right? It's pretty rare that everyone in the room wants to do exactly the same thing. So it's not unreasonable. There'll be some loud civilizations, there'll be some quiet ones, there'll be some blowing themselves up with nukes, there'll be some who are pacifists. And
Of course, just like there's different kinds of galaxies,
right,
different kinds of solar systems.
I mean,
yeah.
infinite diversity and infinite combinations, right? To quote.
I think the most horrific idea is that we're alone, that we're not living in a universe that's filled with life. That this is just some weird freak incident.
Well, I think I'm a little bit controversial because I'm one of the few colleagues of mine, well, I'm not a colleague of myself, but one of the few astronomers I know who concede that we might be alone. I'm open to that idea. I'm not saying it's true.
Well, we don't have any evidence that we're not alone.
I think
so. It is a possibility.
Yeah, I think and it really kind of pisses me off, to be honest, when an astronomer is interviewed in a situation like this. And they're asked, do you think there are aliens out there? And they say, yeah, of course. How can there not be? How can there not? The universe is so big, blah, blah, billions of stars. Of course, ergo, there must be aliens. But we have no idea what the probability of life starting is. I mean, even to make a moderate-sized protein. A protein is just a chain of amino acids, and there's about 20 that go into making a protein. And a moderate-sized protein has 150 proteins in a row connected together. So the chance of amino acids randomly coming together to make even a moderate-sized protein is 20 to the power of 150. So that's 10 to the power of 195, right? So one with 195 zeros after it. It's just incredibly unlikely that would happen by chance. And we've never observed it in the lab. No one's ever got amino acids to spontaneously form anything like a life form or proteins in a laboratory setting. So it is plausible. There's some unknown mechanism that accelerates that process, and we just haven't found it yet. But it's also plausible it was just incredibly unlikely. And maybe if you look out and cross 10 to the 22 stars in our universe, observable universe, there's just one success. Now, the universe is probably infinite, so probably if you travel far enough, you'll eventually come to someone else.
Maybe.
But by all intents and purposes, we may as well be alone in that case because they're outside our observable universe, so who cares what they're up to? So I'm open to that possibility. I'm not saying it's likely, but I think as a good scientist, I can't tell you, yeah, of course there is, because that's now falling into experimenter's bias. I'm deciding what the answer is before I've done the experiment. That's not my job. My job is to figure out the answer.
Of course, yeah. There's no way you could say for sure until we have real information. And it's oddly romantic to think that we're alone. There's something about it, like, boy, we better not fuck this up. We're the only ones.
Yeah. We are essentially we may be the way the universe is conscious, right? We are the way the universe is self-aware.
Well, that's what gets really weird about artificial life. Because if we create artificial digital life and we do have the power to make this like completely ubiquitous and then give it sentience, and then it starts making better versions of itself. How long does it take before it's a god?
Yeah, that's kind of the singularity, isn't it? It just becomes unpredictable.
Well, yeah, I mean,
at that point.
we're really just guessing. Especially, like, I can't understand quantum computing. I've been trying a lot. I've been watching lectures. I've been reading papers. When they start talking, like when Mark Andreessen describes computations that quantum computers have done, that if you turn the entire universe, every atom of the universe into a supercomputer, the entire universe supercomputer would die of heat death before it could solve this equation, and a quantum computer can figure it out in a few minutes.
Yeah.
What are you even saying? Like, what does that mean?
Yeah.
Right? So if this is something new for us as human beings in 2025, which is just impossible to imagine in 1925. Okay, you just go 100 years, a blip, one life on Earth from birth to death, and you have something insane. You have something that's like akin to wizardry and magic. What's 100 years from now?
Yeah.
What is once we give artificial intelligence the ability to harness the power of the universe in a way that we haven't even contemplated? What happens then if it just keeps going and makes better iterations of itself?
All bets are off. Yeah.
Yeah. And we're looking at exponential increase in technological innovation. So you're looking at thousands of years of innovation taking place in minutes. It's just going to fucking hyperdrive. As long as it has the power to do it, it's going to go into hyperdrive. And
Yeah. And so it's kind of wild that we live during the period where this is all happening.
Yes.
Right? How come you could have been born any one of the, hundreds of thousands, in million years humans have been on this planet?
Oh, yeah. I feel so lucky.
You could have been born at any point in human history. And we all happen to be, all of us listening, happen to be born at the time that humanity is going through this growing pains of like figuring out probably the most, deep, provocative problem we're ever going to face as a civilization.
Yes.
And that is wild. And that, if anything, that pushes me towards the simulation hypothesis, right? Because if you were going to study a period, this would be probably one of the most interesting periods that you'd want to study.
The most interesting.
Yeah.
The most interesting. And I feel particularly fortunate that my level of the simulation, the one that I'm on right now, I was born in 1967, so I got to see the whole world with no internet until I was an adult. I didn't get my first computer until I was 27 years old. And I got my first cell phone a little bit before that. And those cell phones were just phones. It was just calling people. There was no text messages. There was no nothing. I have watched this transformation with complete and total fascination. Like, this is one of the wildest moments of human history. And it's amazing to me how easily people just fall into it as if it's not bizarre. Mm-hmm. If it's not something that's completely unprecedented. You could pick up this thing and ask it a question. What year did George Washington die? 1799. I mean, that's fucking crazy. That's crazy. And that's a simple one, right? You could just go on and on.
Yeah, write an algorithm to do this, and it will just speed up.
We're living in a wild time.
Yeah.
And we're all sitting there wondering, when is artificial intelligence going to be a problem? We're all becoming very addicted to using it. People are using it to solve problems, using it to code websites, using it to solve legal cases, using it to diagnose medical diseases.
As a teacher, as a professor, it's a nightmare, right? Because in the classroom, students are all using it. There's been a trend we've noticed that students who take labs, so that's like practical experiments in the laboratory, their scores are always crappy, but then all their other exams and everything else they're doing, the homework assignments, they're all great. And so it seems like that has flipped. It used to always be, kind of the other way around. So it seems like whenever you have to do something where you don't have access to ChatGPT, suddenly you're doing worse than you used to, because we're getting already hooked on it. We're already so dependent on it that the students are just using this as a crutch, right, to get through their studies. So what are we even doing anymore as professors, right?
Are these children really learning? This is the real.
They're learning how to use ChatGPT.
Right, that's the thing. And there's been studies on that about ChatGPT that like actually diminishing cognitive function in people.
Yeah.
And this is 2 years old.
Right. So our IQ could just slip off a cliff.
Off a cliff.
And they could just
come in
smoothly ramp off. And
just give us processed food and microplastics. Just let us eventually breed out.
What a bright future.
Because we're kind of breeding out anyway. I mean, we talked about this yesterday about the population collapse that's in Japan, South Korea. There's a lot of these countries that are like the people that are alive now, like 1 out of a very small amount are going to have grandchildren. And that's crazy. Yeah. You know, and that's also a new thing. And you just wonder if they're all coincidentally happening at the same time. Sperm counts are dropping off at the same time. The introduction of microplastics into the diet that's disrupting the endocrine system. There's increase of miscarriages in women, infertility in both men and women. This is all like at unprecedented rates at the exact same time AI is emerging. That seems kind of coincidental.
Yeah.
It seems kind of weird.
We're being hit by all sides right now, right? There's threat of nuclear war, there's climate change, there's contamination in our food, it's just like everything all at once.
And then asteroids, which I wanted to talk to you about.
Yeah.
I'm sure you followed Avi Loeb.
Yeah.
Like his idea, which he has very fantastic ideas about these objects that are coming from outside of our solar system. And the latest one is this enormous object that's moving at 130,000 miles an hour and is headed our way.
Yeah, 3i Atlas. Yeah.
Hubble makes size estimate of interstellar comet.
Yeah, this is a photo. It just dropped yesterday. Yeah, came out, and this is from the Hubble Space Telescope. So
is this that thing?
Yeah, that's it.
Oh, God.
So, Avi was suggesting this could be an alien spacecraft of some kind. He's obviously done this before with Oumuamua, which you might remember. I think he came on here and talked about that. Yeah.
I know a lot of people are mad at him, though, so I wanted to get your take on it.
Yeah, I mean, I don't like throwing shit at other scientists. That's just not my.
Right.
That's not how I jam. I try to be respectful and appreciative of his contributions, of any scientist's contributions, and I think he, some of his work, I was actually referencing some of his work just the other day to get inspired for another paper. So he's had a huge impact in so many different areas. I do think he's off base on this one, but he doesn't need to be persecuted for that. I just think he's made the wrong call. With this in particular object, so there was three reasons I think why he thought this could be alien. One was the size of the thing appeared to be really big. So it was unclear originally whether it was an asteroid or a comet. And that makes a big difference. If it's a comet, then it's probably a really small thing surrounded by puffy dust around it. So what you see is actually not the true size. The true size is much smaller than what you see. It's just all the coma, as we call it, around it. If it's an asteroid, then that whole thing is a giant rock, right? So it's freaking huge in that case. It'd be like 10 to 20 kilometers bigger than Mount Everest. It'd be a huge piece of rock. But I think Avi's probably made the wrong bet on that one because, as we saw in the Hubble image, there's a freaking coma around that thing. There's no doubt, and we've actually imaged it with the Hubble Space Telescope. James Webb looked at it yesterday.
So it is a comet, then.
Yeah, I don't think there's any doubt it's a comet at this point.
Can you show me that image again, Jamie? So this most recent image, does this sort of discredit his hypothesis?
Not complete. It discredits the idea because his idea was if it's 10 to 20 kilometers in size. That just shouldn't happen. That's too big by chance for a rock to stray into the solar system that's that big, because there just shouldn't be that many big rocks lurking around in deep space. If it's a smaller comet, there's actually a size estimate now that puts it at a couple of kilometers, I think, as the upper limit. Somewhere
it says the nucleus
kilometers.
is 5.6 kilometers. All it could be as small as 320 meters across.
Yeah, so that makes it, as if it's a 300 meters across, I mean, it's just a completely normal comet.
And so
that
image, that indicates a comet versus an asteroid?
Yeah, because you can see this diffuse coma all around it. So that all that stuff. There's actually, even today, there was a paper published that detected water coming off it. So we detected, which is what comets do. They produce OH emission as they fly through. So we know without any doubt it's a comet at this point. But there's still some weird things. It's moving really freaking fast. That was the other thing Avi pointed out. It's moving 58 kilometers per second, which is, hugely quick through the solar system. I think that just means it's old. So generally what happens is as rocks hang out in deep space, they encounter other stars. And every time they encounter a star, they get slingshotted, basically. So they kind of speed up a little bit every time they encounter something. So generally expect that the older something is, the more it's been pumped up in terms of its speed. So Oumuamua was moving really slowly. And Abby said it's moving suspiciously slowly, therefore it's aliens. And then for this one, it's moving really fast. And Abby's saying it's moving so fast, it's suspicious, therefore it's aliens. So I think that doesn't really jibe. I think that doesn't make any sense. It's probably just an old rock that's about 7 billion years old. And that's cool because it's older than the solar system, right?
Yeah.
So if we intercept that thing, we could sample material from not only another star system, but before even a whole solar system existed.
Well, it's going to be here in October, right?
It's already about maybe 2.5 AU from the sun. It's coming in. It will pass behind the sun in October and then come on its way back out. So James Webb is observing it right now, or just a couple of days ago was observing it. And then it will observe it again on the way out in November.
So it's going to be behind the sun.
Yeah. So that was the other thing Abby was pointing out, was the trajectory is a little bit suspicious because it kind of goes behind the sun. We can't observe it when it's at closest approach. That's called perihelion. We can't observe it then because it just happens to be behind the sun. And it comes very close to Mars as well. So it comes within about 0.2 astronomical units of Mars. So it's not like it'd be a threat to Mars. It's still really far out, but it comes suspiciously close, Abby claimed. And to me, I don't buy that as evidence for aliens because, why are they so interested? If they're aliens, they seem more interested in Mars than they do the Earth, right? Why would you choose your closest approach to be when you can't even observe the Earth at all because you're behind the sun, and the closest planet you come to is Mars? That doesn't make a lot of sense to me as to what the motive there would be. So, yeah, and I think the fact now it just clearly looks like a comet kind of pours a lot of cold water on it. But I do think it's not a crazy idea that this could be happening. It's a valid scientific hypothesis that there could be stuff going through our solar system which is not natural. And we're going to detect hundreds of these things with the Rubin telescope. This is just the tip of the iceberg. So I think there's an exciting future for this field to try and intercept these things. There's a mission the Europeans are building called the Comet Interceptor. It's going to launch in 2029. And that's just going to hang out in deep space, waiting for the next one to come. And they haven't necessarily committed to an interstellar object at this point, but they could do it, and they could turn on the engines and catch up with that thing, sample it, land on it. I mean, that would be dope. That'd be landing on an exoplanet, right?
Yeah.
That'd be like seeing stuff from another entire star system for the first time.
Have they found, what is the closest we've gotten to landing on something and taking a piece of it and taking off with a probe?
We've done it with comets.
We've done it with...
The Japanese have done it a couple of times, I think, with comets.
And have they found amino acids on these comets?
Yeah.
They have?
Yeah, amino acids are all over the place. They're in deep space. They're on these comets, yeah. So amino acids are common. Organic molecules are common. We never tested a protein anywhere. So there's a big step. You've got the jigsaw pieces, but no one's seen the jigsaw pieces magically arrange themselves into the right position.
Right. Do you contemplate the idea of panspermia?
Yeah. Yeah, it's plausible. I don't know how likely it is for the Earth because it's just not. It doesn't really help, I don't think, in any meaningful way, right? So maybe you'd say that it depends what you're talking about. Panspermia between star systems, or panspermia just between the planets in the solar system.
Well, between star system. Something from somewhere else. Obviously, our solar system, we're the only form of life. But it's, to me, the idea of something hitting a planet, knocking off a big chunk of it, having a bunch of amino acids on it, and them landing somewhere else. Yeah. So fascinating.
Well,
what is this, Jamie?
Oh, yeah, this was 67p.
This is the surface of a comet?
Yeah.
Whoa.
Probe on the Rosetta.
Wow.
Rosetta mission.
I love these. Yeah, the Rosetta mission landed on Comet 67p. Yeah.
That is so crazy.
Look at all that dust coming off the thing. That's what's happening to Atlas right now. If you could go on the surface of Atlas, it would probably look something like that.
God, that's so wild.
It's so wild when you realize these things are real, right?
Yeah.
This is if you look at the images of like the Mars landers or landing on Titan, you realize this isn't. It's like when you look through a telescope for the first time, you see Saturn, you're like, this isn't fiction. This stuff's really out there. This is crazy. And there's not just this. There's billions of freaking exoplanets across the entire galaxy. It's so mind-bending when you just stop and take a breath and think about what the hell is out there.
Imagine the day when we get a really clear image of the surface of one of those planets, especially one of those water-based planets.
Yeah, yeah.
You see a giraffe.
Swimming around.
There's a lot of people that believe that some forms of life on Earth might have come here from somewhere else, and one of the things they point to is cephalopods. One of the things they point to is like they're so weird.
Yeah.
They're so weird. Cuttlefish are so weird.
Yeah.
Octopuses are so weird. They're so weird. They're intelligent. They solve puzzles. They can open up jars. Their eyeballs are kind of similar in evolution to ours, but they divided hundreds of millions of years ago. And these things exist. What is that, James?
I think this is real.
Yeah, I think this is 67p.
I think this is that comet. It said the image when I pulled it up said this was a video made up of 400,000 different images.
What?
So this might be on its way into landing, or when it was zooming around it, taking.
This is the Japanese images from the comet?
This is ESA mission, I think. The Rosetta
European
mission.
Space Agency.
Holy shit, man.
Yeah, it kind of got stuck in a little ravine, which is kind of unfortunate, actually, where it landed. Because it could have been even more breathtaking if it got a better spot.
It's still so crazy.
I know.
That's so nuts.
Yeah, I mean, there could be all kinds of weird life out there, right? I mean, I was thinking, like, what about if it's just like a fungus, right? It's just a whole planet is a fungus, and that's it. It's never known other life forms at all, and that's just its whole thing.
But also, fungus probably came here from other places, because you think about what's the one thing that can survive in a vacuum? Spores.
Yeah.
Yeah, and tardigrades.
Yeah. I mean, it's certainly possible. I think the problem is that you look at the genetic heritage of life, and this tree of life, and you kind of rewind the tape. There was a great study that's done recently in Nature by Moody et al. And I found it really inspiring, this paper, because they had dated what's called LUCA, which is the last universal common ancestor. So we have a huge number of genes which are the same as each other, but even with giraffes, octopuses, plants, there's a huge number of overlap. So you can kind of retrace the tree and figure out what was the organism that started it all, that like lived at the bottom of this tree. And that's called LUCA. And that thing, they've now age dated it to live 4.2 billion years ago. So the oceans formed about 4.4 billion years ago, and 200 million years after that, you've got organisms. And not just one. These things would have been all over the planet, all over the place. There was a whole ecosphere at that point of these things. So that was quick that life got going.
Yeah.
And that, to me, is probably the most compelling reason to believe that life is common.
And if you would imagine the diversity in what you've just what we know now about solar systems and how different life could possibly be with just a few variables off. Warmer weather, colder weather, more water, less water, some different compounds, different plants, maybe a lack of asteroids, maybe a lack of comets, lack of anything that might slam into the planet. Maybe it lives in a much more stable area. That's not like where we are. We're essentially in a shooting gallery. If something can like have no disruptions, like through civilization, all to the invention of whatever the hell they have there with whatever resources they have there, it's almost impossible to imagine like what we're dealing with and what we're talking about. It's one of the more fascinating things about science fiction is that they don't have any limitations. If you want to have a thing that exists on Earth, well, it has to breathe air, it has to do this, it has to. Science fiction, you could have almost anything.
Yeah.
And when you take into account the fact that we haven't found anything like Earth anywhere else, and you have all these different planets and all these different planets that might be in a Goldilocks zone, and maybe that's not even important because we found life in volcanic vents underneath the ocean. So, like, what's out there?
Yeah, it could. I mean, Europa could have life on the weird exoplanet. So it's certainly possible there's life all over the place. I think what's interesting about the cosmic zoom out perspective of life is why do we live, not where we live, but when we live in the history of the universe. So the universe is about 13.8 billion years old, but it should last for trillions of years. There will still be stars in 1 trillion years from now. There'll be those red dwarf stars that I talked about at the beginning. So we often say like stars are kind of like James Deans of the universe. Like the brighter you burn, the shorter your life. And so these little puny red dwarf stars, they're so pitiful. They're only, about 100 times the mass of Jupiter, 80 times the mass of Jupiter. So sometimes people call Jupiter like a failed star. If you make Jupiter 80 times more massive, it would have burned it would have had nuclear fusion. And those stars, they last for a freaking long time, like trillions of years. And we know they have planets around them. We've even found Earth-sized planets at the right distance for liquid water around those stars. And they appear actually really quite common around those stars. So the mystery is, you know, if you run the calculation, I was actually doing this a couple of days ago, there's about a 1 in 1,000 chance that you would live at this early point in the history of the universe, all things being equal. If these stars legitimately could have planets around them and biospheres whenever they want throughout their history, then you would be it's kind of like reading a book and opening a random page, and that you happen to land on the first, you know, couple of pages of the book, and that's where we land. And that is very difficult to understand for me. I think all things being equal, you should expect to live at the end of the universe or the middle of the universe or something. And it makes me think there's something wrong with these red dwarf stars. Maybe they're just not allowed, or the other alternative is there's a cataclysm. There's something that happens to the universe itself that makes it totally inhospitable to life in the future. That's the other way around it. And that's kind of what this Robin Hanson grabby aliens is trying to do, this loud aliens. There might be AI comes along, it just goes berserk, it just takes over everything, and that's, you can't live 1 trillion years from now because there's nothing left. It's all just AGI at that point. So biological beings could not emerge then.
Yeah.
So we have to come at the beginning, because otherwise we wouldn't be here.
Do you believe in the simulation hypothesis? Do you subscribe to it? Do you consider it?
I consider it. It's kind of philosophy rather than science, I'd say. I did write a paper about it a while ago, and I just kind of pushed back against something Elon Musk said about this. So he said, in a quote, something like, "There's a 1 billion to 1 chance that we don't live in a simulation."
Right.
And he was just sort of running the numbers of sort of, you know, if they run trillions of simulations, then what's the chance you're in the real one? The problem with that assumption is that you have to assume it's possible to make lifelike simulations. And we don't know that's true. So again, putting my good scientist hat on, once we've demonstrated that is possible, then I will agree with Elon Musk on that fact. But until that has been demonstrated, then I'm just going to give it 50-50 odds. But I love this. I don't know if you've had Sean Carroll on here, I think, before.
Sure.
He's a really clever comment about the simulation hypothesis that I've sort of been thinking about a little bit. Maybe you call it like Carroll's contradiction, if you like. And it's the idea that if we are simulated and we ourselves start making our own simulations in the future, and those simulations make their own simulations, you get this kind of hierarchy. And eventually there'll be some bottom level, because every time we run a computer, it's got a finite amount of computational power. So therefore, the inhabitants of that computer must necessarily have less computational resources than we do. Right, because we could run a whole bunch of them. They live in just one machine, so they only have access to what's in there. So every level has less and less fidelity, less computational power, and eventually you'd get to a level where it was kind of like, Donkey Kong from the 1980s or something, right? Where the simulations are just really crappy, and for them it would be impossible to do simulations. So I kind of call this the sewer of reality. There must be a sewer, a bottom level, where you just lack the resources to do simulations. And if you think about it, most civilizations would in fact live in the sewer, because of the fanning out of this tree, they would be the most populous type of simulation out there. So then you have this contradiction, and the contradiction is that we most likely live in a simulation that can't do simulations, but we're assuming that simulations are possible. So that kind of
or
forms,
inevitable.
Yeah.
Yeah. That makes sense. I kind of think about it the same way I think about intelligent life in the universe. We might be the only ones, or we might be the first. It is possible, since we haven't observed anything else. So this idea that we are, the chances, I think he said in billions, 1 in billions.
Yeah.
That we are
it's not like a
living
hard number, yeah.
Yeah, someone has to be the first. So how do we know it hasn't happened yet? Just because we think it's possible, I don't buy into the idea that we're definitely in a simulation. But I'm open to it. I'm open to it because it would be indiscernible. Because you know that virtual reality exists, and if you've used some of the new meta stuff, it's getting pretty good.
Yeah.
But you can tell, but it's getting pretty good. And you can say, okay, Pong to Call of Duty, giant leap, look at the difference, this to whatever it's going to be, and not just haptic feedback, but something neurological.
And the generative AI stuff's so impressive.
But here, right here, it hasn't happened yet. So why are we assuming that it's already happened? That seems kind of silly when there's a lot of like demonstratable realities of this Earth, like that show you things are real. Despite what we know about quantum physics and the weirdness of subatomic particles and the empty space that really inhabits most things, we're here. We're here. This is metal. That's ceramic. Makes noises. There's a bunch of rules. It seems hard. It seems firm. It seems concrete and real.
Seems that way.
I'm not totally believing that this is a simulation. I'm open to it, but I'm also saying, well, if we think a simulation is inevitable because it's, human beings are going to figure, right, but maybe it hasn't happened yet. Well, that makes much more sense to me than we had to go through fucking bell bottoms and disco while the simulation was going on. So if the simulation is real, that means the simulation happened back when Gerald Ford was president and back when the gas crisis was. This is all part of the simulation?
All those memories could be
bullshit. I just woke up.
Right?
I woke up this morning.
I mean, this is kind of like it's a little bit similar to Boltzmann brains. So Boltzmann brains is the idea that, over infinite time, you could just have random particles in space come together to make a brain. It's incredibly unlikely, but like monkeys on a typewriter, there is a chance of that happening. And that brain would have all of your memories. It would, all of the sensations you experience in this moment, but it would only live for a moment. And then it would just randomly fall apart. Yeah. And if you run the calculation, there should be infinitely more of those than there should be things like us. And so this is actually a problem cosmologists, some of them take it seriously, some of them think it's silly, but it is a problem that you end up with this kind of ridiculous conclusion that none of this should be real if you follow this logical conclusion.
Right. But why not? I mean, if we could follow the whole chain from single-celled organisms to us, we understand the competition. We understand like how the weirdness of all we've figured out and all we're working on right now. It kind of all seems logical. Yeah. Like this is where the human race is right now. This is real.
There's no need for such consistency in that case, right? There's no reason why if you're a Boltzmann brain that randomly popped up, you could have total inconsistencies in your universe that don't make any sense, because that would be actually a more likely random occurrence than everything follows a single thread. So that, I tend to think that our lives are probably real. There's not much more we can do about it, but it's not really science because, as you said, it's indiscernible. Even if there were, people talk about glitches in the matrix and stuff like this and looking for weird stuff. But, any good simulator would be able to just rewind the tape, right? If they had an error in their code, we do this all the time, we code in our lab. If there's an error in your code, you just rewind the simulation a little bit, delete the error, and then start again from where you just left off again. So you wouldn't have any discernible glitches.
Right.
So I think it would be totally indiscernible, and thus, if it's no experiment we can do, it fails the litmus test of being science.
Yeah. The idea that we are the first and we are the only one that exists out there, and we are also the one that is creating this artificial intelligence, this artificial life, that seems almost the most interesting one. I mean, it's really interesting, the idea that the universe is inhabited with super advanced life forms that can show us the way and how we can enter into the galactic empire and be friends with everybody. That's kind of cool. Yeah. But it's also almost more romantic and more wild to think that we're alone. Yeah. We're the sole intelligence in the entire thing, and that it's just this weird mistake where the universe wants to experience itself while it's creating an ultimate intelligence.
Yeah, wants to know itself. Yeah.
Yeah.
Yeah, and it's certainly possible. I mean, this kind of goes in waves, cultural waves, right? So if you go back to Victorian times, it was kind of common knowledge that aliens existed. Everyone thought Mars had aliens on it, right? It was just like, yeah, of course Mars has aliens on it. The moon probably has creatures on it. Like, of course there are. And they probably look like us. And then, if you go forward in time, it became unfashionable to believe that. And then Sagan came along and he said, we must be humble. And he had this kind of call for humility he'd often make. He spoke so poetically, I actually kind of disagree with him about that statement. Because I think by making a call for humility and saying, therefore, there's lots of aliens out there, because otherwise it's arrogant to say we're the only ones.
Right.
I don't like that emotional language because it's kind of playing with your emotions rather than your logic a little bit, right? So I'd rather let's just do the experiment and find out rather than say you're an arrogant asshole because you think you're alone. That's kind of making me think, oh, I don't want to disagree with Sagan and say we're alone. That to me, that's a bit of a almost like preemptive emotional bullying to try and like push you into a certain position.
But wasn't that a response to the ideology of the times?
Yeah, for sure. I mean, this is what I'm saying. Like, the times keep swinging, but people often call back to this humility thing. Sometimes when I say that we might be alone, people say, you must be so arrogant, you must be like a super Christian or something to believe this. And none of that's true. It's just, I'm just trying to be objective. Like, it's possible. That's all I'm saying, dude. Like,
be an actual scientist.
Yeah, let's just go out and figure it out. And it would be wild if we're the only place in the observable universe. My guess is there's life elsewhere in other galaxies, though. I think... a natural explanation for all of this stuff we see would be that these AIs do pop up and these berserker civilizations pop up, as they're called, and they just go around and they just cause mayhem in their galaxies. They just convert them all into computers, whatever the hell they're up to. They're just causing mayhem. We could not be born in that galaxy. Right, the same reason why we can't be born in a distant future where the robots have taken over. We can't be born in that galaxy. So maybe 99% of galaxies, that's the way it is. And we necessarily would have to be born in the backwater because we couldn't be born in Manhattan. We couldn't be born in the center of all this activity because we wouldn't be here to talk about it.
Right.
So I think we call this Extragalactic SETI. So looking at other galaxies to look for alien life. To me, this is a really underserved and important scientific endeavor that we should get involved in because those are almost like decoupled from us, right? Because their history has no impact really unless you believe that they can travel all the way from one galaxy to another, but that's really hard. But all things being equal, I think you'd say they are decoupled test tubes. Those test tubes got nothing to do with us, so that gives us a fair chance. But looking at our own galaxy, it may be that we can't conclude aliens are common or rare because it's kind of linked to us. Their activity could affect our existence. And so it's hard to make inferences in that situation.
I was watching a documentary once on hypernovas, and they were talking about during the first discovery of hypernovas, when they were finding these gamma ray bursts, they thought that there was war going on in the universe. And they thought that that's what they were observing.
Huh. Wow. Yeah, I mean, maybe they were. Who knows? There could have been all sorts of weird stuff happening before modern astronomy was able to get involved. But yeah, I think the past is incredibly insightful. But there's mystery. I mean, and have you heard of the Eemian period? Have you ever heard of this period in the past? So we live in this the Holocene, which is an interglacial period. And you need the interglacial period for a stable climate, to have farming, agriculture. You can't live in an ice age, right? Because otherwise you just can't grow crops. So about 10,000 years ago, we transitioned into this Holocene, and then you see civilization emerge all over the world, right? Not just in one place in the Fertile Crescent, but also in South America. It seems like there was almost this random coincidence where just civilization started. And of course, it's most likely because of the climate. The climate had got to a point where humans could figure out how to manipulate the stable conditions to grow crops and farm animals and things. But there was another period about 120,000 years ago called the Eemian, which is the last interglacial period. So modern anatomic humans should have been around then, right? 120,000 years ago, we were here. You could have taken one of those babies and put in our society and really wouldn't know the difference. Probably had the same brain power we do. And yet, as far as we can tell, even though that period lasted for about 15,000 years of an apparently stable climate, civilization didn't begin. So I find that really fascinating. There was almost like a second opportunity, a previous opportunity for us to get this ball going, and we didn't figure it out that first time around.
Was it possible that they figured it out, but not to an extent where it would be recognizable today? 120.
Yeah, they might not have gone as far as us, right? They might have got to some kind of Neolithic stage, but they never got to an industrial stage, or they never got to a space age.
Would we have? Well, never got to a space age for sure. But would we have any evidence of their metal from 100 and X amount of thousands?
Yeah, I don't know. You'd have to ask an anthropologist that.
What would even be left
certainly
over?
a space age we can. They certainly didn't have nuclear power plants. Certainly the fuel deposits don't appear to have been depleted. The oil reserves. They don't see like plastic everywhere from a previous. I mean, because we've created so much concrete and plastic that, I've spoken to anthropologists who say like, there's no way you could miss human, in a geological sense. In the future, even if all of our cities had eroded away, the plastic that we have produced would produce such a huge signature. You'd see this like layer in your rocks. Right. So it'd be pretty hard to miss us. And you've heard of the Silurian hypothesis, this idea that could have been like a past civilization. Maybe the dinosaurs, for instance, could have had like technology and civilization. Yeah,
I've never heard that.
Adam Frank, he was on here a few years ago.
Yeah.
Maybe it was before he came up with this idea. But yeah, he has this fun idea called the Silurian hypothesis. It's kind of borrowed from sci-fi. I think the word Silurian or Silurian, not sure how to say it. But he had this idea that, maybe there was someone, 50 million years ago on this planet, a civilization. And over that time scale, a lot of it does, as you correctly say, get eroded. It's really difficult to put strong limits on them. But I think at the stage we're at now, with the amount of plastic and concrete we've made, and also just having stuff on the moon, right? I mean, there's nothing else. We've imaged the moon every centimeter of that damn thing, and there's no other stuff on the surface except for what we've put there. So at this point, we can be pretty confident there was never a space age civilization in the past, despite the fact there appear to be opportunities, right? And so maybe the emergence of civilization requires just the right conditions in some certain way. But then it is spooky that it happened 3 places.
Well, also you have to take into consideration it takes a special kind of person to innovate to the point where everything jumps off of this one invention. Whether it's the combustion engine, whether it's the transistor, whatever it is, nuclear power, splitting the atom. It takes a very specific type of intelligence and resources to create this thing that transforms everything. If no internal combustion engine, no electronics, no electricity, that is possible. So we're all living exactly how people lived just a couple hundred years ago. That's not that long ago.
Yeah.
Right? A couple hundred years ago, no engines, muskets, they'd barely figured out gunpowder. Like, you're looking at a whole different world. No electricity, candlelight everywhere, whole different world.
Yeah, it's like when you talk to a World War I veteran.
Yeah.
It's crazy the world they lived in. Yeah.
And that's not that long ago.
Yeah.
So it takes specific types of human beings in order to push things radically past where they are now, like Orville and Wilbur Wright.
Yeah, you certainly probably need a critical mass of humans, right? You probably need enough that there are some humans who can just not do the farming, not be involved in hunting. They can just sit on the side and just use their brains to think about problems.
And they're going to have large-scale cities where they can get food and resources and other people like them to collaborate with.
Yeah.
It's probably really hard to pull that off,
right?
Especially when you're dealing with territorial nuclear-powered apes.
Yeah.
It's like probably really hard.
So the question is, if you reran the tape, if we could go back and rerun the Holocene over, is the emergence of the Neolithic Revolution, eventually even all to the Industrial Age, is that an inevitable thing that just always happens? Or would there be other realities where we were just quite happy living as hunter-gatherers?
Or things go off in a completely different direction, like it appears they did in Egypt. Like whatever they were doing, 2,500 plus BC, whatever they were doing, it was very different than everyone else in a spectacular scale. In a scale that today, thousands of years later, we look at it and go, I don't fucking know. No one knows. They all pretend there's a logical, people were smart, they figured it out, pulleys, this, that, the other. Right. You do it. Do it. If I give you $1 billion, can you make me a pyramid? Fuck off. It's crazy. It's a giant mystery. It's clear that it's there. It's clear that it's in this one part of the world that for some reason, those people were way more advanced than everybody else.
Yeah.
Way more advanced.
They figured stuff out.
They figured out
how to move. But that's not so hard to
move
believe, right?
Enormous blocks of stone, hundreds of miles through the mountain with no machines.
Yeah.
Like they were doing something totally different than everybody else. How?
Right, but this is the same species that figured out how to split an atom.
Yes,
right?
unquestionably, but that's my point.
We can put our minds to it.
100%. That's my point. They went in a different direction. We're fucked because of the Library of Alexandria burning, and there's just not enough records to explain. But we know that they did that. And we know that human beings did that. And we know that human beings did that within the last few thousand years. So that was a totally different direction. And we're just collectively agreeing that this direction is the way human beings go. But it's just what we're caught up in right now.
Yeah.
Like there could be a ton of different ways to do this and to seek technological innovation and to seek consistent, constant evolution of technology to the point where you can do that with these giant stones and you can point it to true north, south, east, and west, and you can set it up at, it's like, I don't know how many acres the Great Pyramid of Giza is, but there's 2,300,000 stones in that thing. Yeah. It's just nuts.
Which is a good motivation for doing simulation, right? Because we would love to, you want to rewind the clock.
Oh my God.
That would be, let's let the Egyptians take over. Let's see what happens in that world, right? I mean, that would be a fun, the biggest tragedy I find of being alive now is I want to know, I'm fascinated by our story as humans. And I want to know how it ends. I want to know what is the future? What does it look like in 1,000 years? Are we still here? 100,000 years? I mean, we should still be anatomically kind of not evolved too much at that point, all things being equal. So I'm fascinated by us, like where I think we are the most fascinating thing that's ever happened to this planet. And I think it's such a shame that my finite lifetime means I will never know where this incredible story eventually goes to.
Yeah, I think it's kind of like No Country for Old Men. Sometimes it ends and it's just you're
dust.
Like, damn, I want to know more. You can't know more. You're gonna your time here is done. Yeah. This story goes on without you. I mean, it'd be kind of cool to find out how it ends. I suspect that it ends with us looking like the Greys. I think that's what that whole thing is, that bizarre iconography, this bizarre imagery that we have, this iconic creature that is completely non-muscular, has no gender, and has an enormous head. I think we're going in that direction. I think that's almost like some beacon in the future that's like calling to us in our subconscious. Like when people have these late night experiences where they think they're being abducted and they're encountering that. I think it's almost a part of our genetic coding.
I wonder if it's more of a cultural feedback. Because, Adam wrote a book about UFOs recent, Adam Frank, and he was telling me about their story that when the first UFOs started to be reported, the first flying saucers, like around Roswell in the 50s, that there was a farmer or something that was being interviewed and he saw something, and a journalist came and interviewed him about what he saw, and he described something, and it was not a flying saucer, but the journalist misheard him. And wrote down flying saucer. And then in the years that followed, there was an explosion in the number of eyewitness reports of flying saucers. But it all happened after it came into print, that this concept had almost been, the idea, like a meme, had been put out there. And once the meme's there of the Greys or the flying saucers, when you're in those delusional states or whatever it is, you're in some kind of weird perceptional state, it is possible that your brain reaches for something and it reaches it and it finds that meme and it's Definitely. Like that could be that makes sense because that's all it's got for context. So my guess would be it's more of a cultural phenomenon, but you should chat to a sociologist or psychologist about that because I'm sure they'd have a much more informed opinion about what's going on there.
Yeah, I think there's some elements of that for sure. I don't think there's any hard, fast explanation for all of the things. You could put them all into one category, all the sightings. But for sure, people do see what they want to see. I remember one time I was in the woods in Alberta, and I saw what I thought was a wolf. I thought it was a wolf because they had a lot of wolf sightings up there, and I thought it would be pretty cool to see a wolf. And I thought what I saw was a wolf. I thought it was a wolf for 2 seconds. It was a squirrel. But for like a second, maybe two, I thought it was a wolf. I'm like, what? Is that a fucking wolf?
Yeah. I
thought I saw a wolf. I'm like, oh, it's a fucking squirrel. That's crazy. How do you think a squirrel's a wolf? Right?
Your brain just reaches for it.
Because my brain was reaching for wolf. Luckily, I'm logical, and it was clear that it was a squirrel. But I was seeing it in dense woods, and it was moving through, and it was gray. Yeah. And my perception was wrong in terms of distance. So I was like, is it? Oh.
Yeah, there is a phenomenon called Gestalt reconfiguration that psychologists talk about. And I know about this term from Mars. and the claim of Martian canals that used to be there. So
Right.
there's this phenomena, there's these laws of jet dot reconfiguration. It's sort of like closure. Like if you see dots that almost make a circle, your brain will kind of make it a circle in its mind. Continuation, that if you see like dot dash lines, your brain will see a continuous line almost. It'll fill in the gaps. And so the same thing is thought to have happened to this famous astronomer, Percival Lowell, in the late 19th century. So he was like this like super rich dude in a Boston area. He was from a wealthy family of industrialists, and he got really into astronomy. And so he was convinced life was out there. That was, A, he was wealthy, so had means. B, he thought life was out there. There was a quote from his memoir, and it was something like, that what we call life is an inevitable detail of cosmic evolution as gravitation itself. So he just thought like, it's just, this always happens. Life always happens. And on top of that, he'd been told by the Boston ophthalmologist that he had the best eyesight the ophthalmologist had ever seen. So he had these like three things in his head. He had, I've got the means, so I can do it. I've got the best eyesight anyone's ever had, and I believe that aliens are out there. So he looked at Mars and he saw these 4-inch telescope or something, like a really blurry small telescope. But he was able to make out these little patterns, and he thought there were canal systems because he saw that going up all around the United States at the time. He even did it for Mars, and he saw, this is crazy, he drew a similar kind of picture. Maybe you can Google it, Jamie. Percival Lowell Venus, and you'll get these kind of spokes. And he saw these maps of Venus that, of course, were wrong, and they look like the back of an eye. They look like the blood vessels on the back of an eye. And so ophthalmologists actually think that's what he was seeing. So if you go to the left, the next one down, that one there. You see that? So that's the image he drew on the right. And that's the image of a back of an eye. And his eyesight, it's thought, was so good, he was seeing reflections of light in his own eyeball.
What?
And was seeing his own blood vessels. So he was right. His eyesight was freaking awesome. He was correct about that. But he misinterpreted it to be living things on Mars.
Oh, wow. So he's just a freak.
Yeah.
Just a biological freak.
Yeah.
That's crazy.
So this is I think this story is fascinating because it's a real warning shot of if you really believe aliens are out there, like you're convinced about it, every time you see something weird, that's where your brain goes to first.
Yeah. No, there's no doubt. There's no doubt that that's a case. But I do wonder about some of the sightings. But it's always wondering because I have not had any experiences personally.
You've never seen one yourself?
Nothing.
No.
That really freaked me out. Nothing that I could say was something that I could go, there was this time. No.
Well, I haven't either, and I think a lot of astronomers are in that same boat. And I think that's kind of strange. Right? You'd think the professional people who stare at the sky for a living,
that's real weird,
would probably have the most number to rack up, unless we're all in, maybe a conspiracy or something.
But that is also the question is, are we looking at it wrong? Because if you're dealing with something that's so technologically advanced that it's a million years ahead of us, would it really be still doing that, flying around in ships?
Well, who knows?
Would it be able to teleport to areas? Would it be able to completely hide, be totally invisible?
But I guess the problem is there's all sorts of weird crap out there that we just don't understand. In the NASA UAP task force, they found this. Maybe you can find, Jamie, red sprite lightning. There's these lightning events that go upside down.
Yes.
And it happens in the upper atmosphere. And for years and years, pilots were reporting this, and nobody believed them. They were like, this is bullshit. You can't have upside down red light. What the fuck are you talking about? That's crazy. And then people started videoing it. And once they got videos and high-resolution photographs, you have to have like a shutter frame rate of like 1/100,000 seconds or something crazy to capture these things. And until like the 1980s, we just thought this was basically a myth. And then we realized this is going on in our own atmosphere, and we didn't even know about it. Right, so we don't understand.
Tell me that doesn't look like War of the Worlds.
Right, if you saw that,
oh my God, there's an enormous ship the size of Manhattan flying over us. Like, look, that's so crazy. It was probably ball lightning, right?
Yeah, same thing with ball lightning. I guess that one's maybe a little bit less. I think they've maybe made examples in the laboratory, but no one's got hard video of it in a real world setting.
There's no hard
I
video
don't
of
think
ball
so.
lightning? Oh,
I mean-
I thought there was.
All that shit online is fake shit.
Oh,
Yeah.
no. Really?
Some AI.
I talked to a guy who had something fly through his home, and he was like a regular guy, didn't seem to be a liar. We were doing this TV show for the Sci-Fi Network, and it was all around Skinwalker Ranch.
Yeah.
And this guy said that he had this ball of light that came through his home.
Wow.
You know, but if ball lightning is real and it does just sort of fly around, that is possible. I mean, it wouldn't
It's
be
possible, yeah.
limited in terms of its ability to go into a structure.
It's kind of surprising we don't have any good video of it at this point.
Right.
But
I thought there was video. I'm
Here's
such a
2 weeks.
dumbass.
This might be. I don't know. I'm not saying it's real, but this was 2 weeks ago.
Well, she's definitely not really there.
No,
so
obviously
right away we're fucked because right away they're doing
She's
trickery.
green screened on top, but that
I know,
in the
but-
background.
But right away we're doing trickery because this lady is not really there. So you're asking me to say that this is real when I know that this lady is in front of a fucking green screen.
Just there's a video that was going around. That's all. A lot of people are
Okay.
making.
Can you show me it again?
That's what I was trying to.
Anton's got good stuff. Yeah,
Oh, okay, cool. Anton Petrov.
Yeah.
Shout out to Anton.
He's one of the good ones.
Cool. So this thing, what is Anton's take on this? Is it bullshit?
I haven't seen his video, but he's normally pretty grounded.
Yeah, they're mostly all bullshit. But just again, there's a new one. Someone thought they caught.
Interesting.
You know,
Interesting.
my sister, when I was a kid, used to make me come into her bedroom and check for ball lightning. She'd be like, she'd heard the stories that it chases you around. So she'd be like,
Oh,
look
wow.
behind the curtains. And she's my older sister. I was like a little 7-year-old having to like look around her room to make sure. But it's one of those things that like you get kind of terrified of the notion of it. Yeah.
Isn't part of the theory of it is that it involves tectonic plates and that there's some energy that can be generated from
I have no
that. They
idea.
fly out. Because I've heard of them actually flying out of the ground. Is that part of the theory?
It's not a field I follow closely.
Yeah.
I do worry about. I'm getting my pilot's license at the moment, so I'm having to learn a lot about weather and different weather phenomena. So that's been kind of fun learning about and different conditions for lightning and stuff. But yeah, it's ball lightning. I can safely say as a pilot, I've never seen.
Well, if you're out there flying around as a pilot, I really hope you see a UFO.
I do.
Yeah.
I'm always looking out for it.
Of course.
I'm like, man, like, how can I? Everyone else seems to have seen these things. How come I've not seen one? I'm the alien guy. Like, this doesn't make sense. So, yeah.
I wonder what percentage of the population has actually seen something that they think wasn't from here.
Well, a majority of Americans believe in
Yeah,
alien UFOs, I think.
because it's
Yeah.
fun.
Yeah.
And this is also a thing that you were ridiculed for relentlessly up until, I would say, I think the real breaking of the ice was that 2017 New York Times report.
Mm-hmm.
So when the New York
Yeah.
Times had it on the cover,
The Pentagon
yeah.
videos, yeah.
that was probably the first time that people, well, it's in the
Yeah.
Times.
That
now
shifted
I
the
can take it
Overton
seriously.
window.
Yes. Yeah, I agree.
Yeah, I mean, that's actually made, to be honest, that's made the kind of stuff we do, the SETI work we do. So SETI's Search for Extraterrestrial Intelligence. We've kind of rebranded it these days as technosignatures. But that used to be the sort of thing that Congress would always ding and be like, you can't do that. You can't have, taxpayer money going to looking for aliens. That's ridiculous. But ever since, the UFO, the UAP phenomena really caught on, the Overton window has shifted, and now what we do seems completely like, if anything, like too traditional and we're too conservative in our approaches compared to what other people want to do. So now you've got Avi, who's trying to do Project Galileo, right, to actually look for UFOs in the atmosphere and stuff. And I think it's a valid point. Like, you can't say that looking for aliens on an exoplanet is good science, but looking for aliens in the atmosphere is not science. Like that, it's still, you can design an experiment to do it. It's still scientific. There's no magical reason why once it enters the atmosphere, it suddenly doesn't become science.
Yeah.
So I think that's a good argument why we should do it.
What is your take on all these UAP whistleblowers who talk about crash retrieval programs and all these dark-funded, top secret, beyond anyone's ability to go look into them?
I don't know what to make of it. It's
Yeah.
fascinating. It's because I can't believe maybe some of them are pulling our leg and bullshitting it for the fame or whatever. But there's so many credible people that have come forward. It's hard. It's difficult to pass what's going on. But I do believe everyone's fallible, right? So it is possible. There's, as I said, there's so many millions of hours in the air of these pilots and things. There's so many so many people, so many cell phones, so much out there that it's not surprising that 1 in a million times a mistake or something could happen. And it's all about knowing that spurious rate. Like, how often do you just randomly generate bullshit in this whole system that we've got? And we don't know what that bullshit occurrence rate is. So as a scientist, it's hard to pass it. I don't think we can ingest it realistically unless, every time they say they've got the disclosure thing, right? We're going to get disclosure soon. And every time it feels like we don't get the craft, we don't get the technology, we don't get a body. So yeah, sure. If you give me the technology and let me dissect it in my lab, then I could be convinced. But every time it seems like we get all the way up to that point where it's like, it's going to happen, and then
it's intensely frustrating. It's intensely frustrating to even be remotely interested in it, because every new thing you're like, what? Is this it? Is this going to be a thing?
They're
and
like pulling on your
never is.
heartstrings. It's like a girl who keeps texting you saying like, we'll go on a date, it's going to be great next time, and then she just lets you down every time.
What is the name of that Age of Disclosure documentary? That's what it is, right? Yeah. There's a documentary that they premiered at Sundance, or at South by Southwest rather here, that was really good. And it is essentially just all these different people that worked on these programs spilling the beans. And they all have pretty similar stories. And the bottleneck seems to be that all this stuff was done without congressional approval, which is highly illegal. So all the research, all this hidden back engineering programs, all this stuff in conjunction also with military contractors. So those are the ones that build the jets and the rockets, and so you have to go to them to help with this stuff and to try to back engineer this stuff. So then there's this competitive advantage that they would have over other military contractors that don't get a crashed UFO. And so then people are getting sued, people are going to jail. There's a lot of money that was allocated for these things that was done through lies. And there's a lot of problems with that. And with this documentary is essentially calling for mass amnesty and saying, look, if this is real, and they think it is, this is a situation that is, forget about whatever laws we have in terms of finance. This is a much bigger deal. There is direct evidence of an actual life form that is not Homo sapiens, that can do things that we can't do, that visits us. And occasionally they lose a craft, which is also hard to believe, right? How did they get here?
They're not very good pilots, right?
Richard Dolan actually has a pretty good explanation for some of them. And it's high-altitude nuclear bombs that we detonated during the testing days. So during the testing days, which after the war, from 45 to, I think, they tested them, when did they stop blowing up nukes? But there was, just in the United States, thousands of nuclear detonations. And a bunch of them they did in the ocean, and a bunch of them they did in the sky. Yeah. They did them 150 miles up. They detonated nukes. I thought they only did it once with Starfish Prime. But no, they did it at different altitudes. Right. They did it. They just tried things. And the idea is that if there was something in the sky anywhere remotely near that, and had no idea this was going to go off, and they detonate a nuke in the sky, that this thing would crash.
Oh, knocked out the sky.
Yeah.
I mean, it's a great story. I just need to see the evidence, right?
Yeah. It's the best story.
Yeah. I think it could be, in Iceland, most people believe in fairies. And if you go back, 100 years, most people believe that.
Most people in Iceland believe in fairies. Yeah. Wow. What do they think they are?
I don't know. Elves, maybe elves or fairies. Can't remember the exact word they use. Yeah. But they
Soviet, what does this say, Jamie? What they did?
Last high altitude test.
Okay, so the last high altitude. Look at how many they did. They just kept doing them. Yeah. They just kept doing them. Look at all these fucking tests. These are all high altitude nuclear bombs.
So a bunch failed. Yeah.
That is insane. Yeah, a bunch failed. Look at all these ones that failed. What happened to those? They just fall into the ocean. Good luck. Figure it out, fish.
Whale had that for lunch.
Yeah, figure it out. That's where Godzilla comes from. Literally, the movie.
Yeah, I guess my point is that there's whenever we have this weird stuff, aliens is. I read about this recently. Aliens is almost too good of an explanation.
Right.
Because it can explain everything. There's nothing you can't explain with aliens, right? Whatever it is. And yet, so it has, I call it unbounded explanatory capability. You can explain absolutely fucking everything. Yeah. It's God of the gaps, quite literally. Whenever you see something odd, you can just inject your God to explain that. And yet at the same time, on the other side of the coin, it also has unbounded avoidance capacity. Because you could say to me, look, I saw a UFO at this site on Monday, on Tuesday, and on Wednesday. So come Thursday and we'll see it together because it's happening every day. And I come with you, I don't see it, and but okay, well, it just didn't. I guess it changed its mind. It didn't happen today. That doesn't disprove what you saw. And similarly, if I go, people have said, we've surveyed the surface of Mars. We don't see any life on it. I can't disprove there's life on Mars. There could be life underneath a rock that we just haven't turned over yet. You can never disprove. You can't prove a negative. So it could always be there. So aliens is almost unscientific as a hypothesis because it can explain everything, and yet there's no experiment I can do to ever prove it's wrong. Right. And that puts it in a very precarious position scientifically.
Right. Yeah, we're just sort of in this adolescent stage of understanding. And we if they are real, we really don't know right now. And that's the weirdest part, is that there's so many compelling stories. Yeah. It's also, the weirdness of it is so exciting to us. The weirdness of an intelligent life form looking at us is like so exciting to us that we want it to be real.
You want to believe.
Oh, me more than anybody. I'm the worst. I'm the worst. I go back and forth on it's bullshit. My general belief is that a large number of these things that we're seeing are top secret military aircrafts. And I think that's always existed. That's always been the case. And they probably have some incredible technology that we're not aware of. That's the majority of what I think is happening. But that doesn't make sense when you go really far back. That doesn't make sense when you go to the Kenneth Arnold sightings. Like if his estimations of the speed of those things is accurate, you're dealing with something that for sure wasn't available in 1952, at least as far as we know. Also, the idea that that was Nazi technology, this is something that's always talked about, and Richard Dolan talked about in his book as well. They were already gone. Right? They had lost the war. There's no way they're launching technology that's above and beyond anything anybody is aware of while society's in shambles, right? There's no way. They don't have a military anymore. It's over. The war's over. So that doesn't make sense. So if it's not them, who is it? Is it someone that's already here? Is it something that's been here the entire time? And then that gets really weird. And people go, well, where's the evidence of that? Well, right. There's no evidence of that. But there's also so much room in the ocean. The ocean is, if I was going to hide, that's where I would hide. We literally can't go there. There's too much of it. You could go into the ocean and put a base underground in the middle of the ocean, and 100% we're not going to find it.
Yeah, I would just say whatever your hypothesis is, the most constructive thing to do is to think about how can we prove or disprove it.
We can't.
That's what I want.
Until something, but this is the most frustrating thing about this disclosure jazz. Because if they really do have something, boy, you're fucking over the entire human race by not releasing this just because you're worried about Congress getting mad at you. That's a real problem. That's a real problem. That's what this movie tries to address, and Richard Dolan talks about that in his book as well, and a bunch of people have brought up that point. There's a lot of legal issues that are going to arise, and a lot of people could be very vulnerable if this does turn out to be the case, that they have had this technology since the 1940s.
Yeah. I mean, we can argue about history, but I think the most constructive thing is just to design an experiment. And I think, Avi's idea, Project Galileo, is a good one. We should try and survey the sky more systematically. And we've got now the Vera Rubin telescope, which is doing literally a movie of the entire sky every night. So I think as we grow in our capabilities, it's going to get harder and harder for this UAP hypothesis to evade all of these facilities that we're building in a public domain. Right? This is public data, not military-controlled facilities.
They're very aware of our capabilities and very aware that we can do this, so they camouflage themselves.
Yeah, but then you're starting to get into this sort of, exponentially contrived.
Yeah.
Because they're in our heads and they know everything. So then it becomes unfalsifiable. So we're sort of leaving the world of science. But I think, when we think about as a scientist, like we're doing this experiment with JWST for exoplanets, like we are looking for life right now with James Webb. There was even a claim for a planet K2-18b. There was a claim a few months ago. It's an ocean world. It's thought to be an ocean world. It's about 2.5 times the size of the Earth. And we detected this molecule with weak significance. I want to emphasize that. It was only weakly detected, called dimethyl sulfide. And I think it's the same molecule which gives truffles that smell that they have. Oh. And it's something that bacteria and phytoplankton make on the Earth. So they detected the hint of this molecule. And as far as we know, only life can make this molecule on the Earth. We don't have any other process that can make it except for living creatures. And so it was a lot of excitement about that. And it turned out in that case with follow-up observations, it maybe is not as secure as they thought, and it actually doesn't appear to be there anymore. But I guess the point is that James Webb can do the experiment. It is sensitive enough to look at a planet which is 100 light years away and detect the molecular signatures of living creatures on that planet. So we are entering a very exciting era where we can look at their planets. We don't have to wait for them to visit us anymore. We can actually start surveying where they're at and seeing what's up. So I think that's and that's just simple life, of course. That's not even technological life. So I think we're going to get answers. And the only way to do this is to keep, supporting missions like NASA's mission with these future observatories that are trying to get us to that point. We're trying to build a mission now called the Habitable Worlds Observatory, HWO. It'll probably get renamed at some point. I think it'll be like the Carl Sagan Observatory. Probably will be a rebranding for it. Is my hunch. And that thing's trying to take photos, like we saw for Alpha Centauri. It's trying to do photos, but of Earth-sized planets. JWST can't image Earth-sized planets; they're too small. This thing will be able to take photos of Earths around other stars, and we'll see the pale blue dot of light of that other world, and we'll get its chemical fingerprint. We'll be able to sniff its atmosphere. We'll pull their pants down, right? We'll get the whole thing. So the aliens can't hide from us forever, right? Our technology is getting to the point where we're going to find them in their own home.
When they came out with the James Webb Telescope, how long was the development process? And where are they at now in terms of a future better version of something like that?
Yeah, it was a long process. I mean, almost as soon as Hubble launched, they started planning the successor to Hubble, which was James Webb. It was famously over budget. I think the original budget was supposed to be $800 million and it ended up costing $10 billion. Isn't that crazy? It just went completely overblown. But this is always because, there was some bad contractors. Astronomers tend to underestimate their budgets a little bit when they're planning these things out. And there's inflation. So these things, if you do a project over 20 years, which is what it ended up taking, because it was 1995, I think, and then we got it in was it 2021, 2022, actually ended up getting in the sky. So it took a long time, right, for that project to develop. We are starting the HWO project now. There's already design teams, working groups that are putting the first, blueprints together of what this thing would look like. But of course, it's in jeopardy because the White House wanted to slash the NASA science budget by 50%, which basically just ends that entire program. There's about 40 missions that would end, NASA missions that would end in that White House budget. But fortunately, the Senate readjusted it back up to pretty much last year's levels.
Why don't you go talk to those people? Why don't you give a speech the way you just laid it out for us and how fascinating and important this stuff is? Right. I don't think these assholes know.
I've been to DC. I have lobbied, but you only talk to their aides, right? That's all you end up talking to.
Yeah, you've got to get in front of Congress. You've got to get in front of these people where the American people see it on television and get a chance to understand, this is...
I do it. Yeah.
This is one of the most important things to look for that you could even imagine.
And we can do it. We actually, for the first time in human civilization, we have the ability to do the experiment, is there life on another planet?
What is this, Jamie? This is some of the images from the Hubble?
This is showing what the new telescope, the Roman telescope would show.
It's just a huge field of view,
so
Roman.
That picture is what the Hubble got, and then it's zooming out to show you what.
So Roman's happening, hopefully. Yeah, Roman should be flying.
Oh. Wow.
Roman, interestingly, is it's military technology, it's spy technology. So apparently the NSA had 2 Hubble-class space telescopes in their basement. They just said to NASA, by the way, we're not using these. They're out of date for us. Do you want one? And NASA took it and turned it into Roman.
That's crazy.
They just have them lying around.
That's what I'm talking about. These motherfuckers have technology they're keeping from us. What could be done better? Like what is, if you had an unlimited budget and an enormous supply of brilliant minds to get together to coordinate something, what would be how you would set it up to make it even more powerful?
For what goal?
Seeing further, seeing clearer, being able to precisely locate planets and get a much better view of them.
Yeah, I think, as I said earlier, whenever we improve our instrumentation, our precision, by a factor of anywhere from 3 up to 10, let's say, in that ballpark, like a big improvement, you get surprises. You find stuff you never expected in the universe. And we've seen that every time. So
every time.
Yeah, I think whenever you listen to the universe in a different way. So we were, for years and years, we've just been using our eyes, basically optical light, to look at the universe and X-rays and radio waves. And then recently we started doing LIGO, and LIGO's listening for gravitational waves from the universe instead. So it's like listening to the acoustic oscillations of the universe rather than seeing it. And again, as soon as we started doing that, we discovered tons and tons of merging black holes, and it's just totally transformed our idea of how black holes merge and form. So whenever we do something we've never done before, look in a different way, the universe constantly surprises us. So it's not going to be a single mission. It's not going to be, we should all just put all our eggs in this one basket of Habitable Worlds Observatory. We need to have this multi-prong attack of let's just keep pushing everything and making sure it's a significant improvement from what came before in terms of the sensitivity, and making sure the scientists to actually interpret the data at the end of the day, right? You can't do science unless the data is A, public, and then B, people are actually there to study it. So those are the 2 key ingredients. Just have great telescopes and great people.
Is funding the biggest bottleneck for it right now? Or is it a lack of interest from the right amount of people? Like, what is it?
Yeah, certainly. I mean, HWO, we're talking about a mission that's going to cost at least $10 billion. And the NASA budget is about 26 billion. So it's eating up already. I mean, if you built it in 1 year, it would eat up almost half of the budget. So it's impossible for that mission to be built in a year, even though probably we could if we had the money. Maybe in a year or 2, you could probably build something like that. So that, yeah, if you doubled NASA's budget, it would come twice as fast, for sure. You'd have it in maybe 5 years rather than waiting to 2050. That's what we're talking about for HWO. It's just kind of depressing when you think about it.
Well, what's kind of depressing is like weird stuff happens. Like when the Biden administration left, $93 billion in loans just went off to like weird places, like which is more than they had done in 15 years. Like, you guys could have done that.
You have the money.
You guys had the money to make the most insane telescopes.
Yeah.
We could find out more.
Yeah, I think Carl Sagan had a quote once. He said that the entire SETI program was equivalent to 1 attack helicopter. If you did like the entire SETI in its maximal form, would have been the cost of 1 attack helicopter.
Dude, if I was president, I'd go ham. I'd bring in all the cosmologists. I'm like, what do we got to do?
Let's figure this out.
Let's get
now.
crazy. Let's get crazy. You guys want to get rich?
This image shows telescopes that we have used, and then a few that are being made. So down here is the size of the James Webb telescope. It's all the way down.
Yeah, I mean, it's limited. It's only 6.5 meters, so it's limited. They couldn't really make it any bigger because you couldn't get a rocket that could fit it. So actually, Starship could launch that thing without any unfolding. It wouldn't have 200 points of failure. It could actually pretty much fit inside the fuselage of Starship. And even better, it would cost less because a huge cost in these space telescopes is making them really light. So the mirrors are like these special honeycomb structures to make them super light, so they're low cost to launch. But if you have Starship, it can launch like 100 tons, I think it is. You could literally just take these ground-based telescopes you already have and just shove them in there and, obviously put some chassis on it. But it'd be way, way cheaper to launch these things. So, I mean, I'm very excited about the prospect of having heavy launch capabilities that Starship give us. That plus investment in something like these kind of giant telescope designs, we could launch some truly gargantuan things into space and probe those atmospheres and see those aliens and what they're up to. So I would say the future can be bright because we have the means to do it if we have the will to do it.
It just seems to be a puzzle that most human beings on Earth are fascinated with. The fact that that is inadequately funded is enraging.
Yeah.
It's enraging. It just makes you crazy. Like, out of all the things that we should be interested in, that seems to, space seems to be the big one. And it was until we were all fucked up by light pollution. I think if we didn't have light pollution, I think people would have a much greater sense of the majesty of our existence in the cosmos. It's such a bummer. It really is.
Have you been to a dark skies area?
Yes.
Yeah.
I've talked about it too many times on the podcast to repeat it, but there was a time when I went to the array in the Big Island,
Mauna Kea.
Mauna Kea,
Yeah.
and I went up there on the perfect night. There was no moon, and it was like being in the hub of the universe. It was like being in a spaceship, a convertible spaceship. That's what it felt like. It was so incredible. The entire sky was filled with stars. The Milky Way was beautifully clear. And it was like life-changing. I've gone up there 3 times since, never caught it that way again.
You get kind of like the overview effect. You heard that with astronauts when they go up to space
Yes.
and they see the Earth. And I think
exactly what
we
it
should
was like.
launch all our presidents into space.
Oh, that's a good idea.
Bring them back, but let them have that
Yeah.
overview, because I think that is...
Launch it with Katy Perry. Everyone has to go up with Katy Perry. She has to bring a daisy.
She's the guide.
Yeah, I mean, I think that would be great for people. I also think they should have a mushroom experience, but that's just me. But going into space, just being able to see it used to be the norm for human beings. There was no light pollution. You could get away from the campfire, you lay on your back, and you see everything.
Yeah.
And I think that gave us a better understanding. First of all, it made us more humble, for sure. You're confronted with this impossible image in front of you. And now that we know what that is, so ancient man's looking at it, it's just incredible, beautiful lights, and they're tracking the constellations and marking them down, and this is what this is. Let's call this one Leo. But when you get to what we know now, and what we know, those are all fireballs in the sky that are bigger than our sun, and they're millions of miles away, and that you're seeing just a tiny fraction of what the actual universe is, which is really nuts. Yeah. When you see, like, I'm sure you've seen this, but maybe people haven't. When there's an image of what you see in the night sky, when you have a full, clear view of the cosmos, and it's this tiny little itty-bitty little thing. And yet it's still insane and majestic. And I think that we've gotten so arrogant because of cities, because everybody just sees this black cloud over us, this curtain over the sky, and maybe you see the moon, but that's it. You see a dot here or a dot there. That's the only stars you see, are the most bright ones, or Venus. And then you don't get a sense of what we're really doing.
Yeah, it makes me sad when...
So here's the inner city sky, suburban, urban, rural, excellent dark sky. But then what the thing about the observatory is that it's above the clouds. We drove through the clouds when we saw it.
That doesn't even do it justice.
No, not even close. But there's pictures of it. See if you can, the Mauna Loa Observatory.
Yeah, I think what makes me sometimes sad as an astronomer is sometimes people say, what's the point of looking for life out there? Like, I care about the bread on the table economy and jobs and factories and stuff like that. I care about the things that really directly affect my life. But I think there has to be things that we do as humans, existential things like, are we alone in the universe? How can it be a bigger question than that?
That's what I saw.
Yeah.
Maybe even better than that.
And when you see something like that, you realize that there's more to this life than just substance, of just staying alive for the sake of staying alive. There are grander things than what we have on this planet.
Also, it's so frustrating that we're very capable of curing all those problems for the vast majority of people on this planet if we weren't so fucking greedy.
Yeah.
If we really treated humanity like a community, we could completely eliminate starvation and poverty the way it exists today.
Yeah.
We can completely, no one's even tried.
Yeah, the inequality right now is so out of control in this country and the world.
Well, in the country, but in the world, the craziest thing that I've ever heard is that $34,000 is 1% of the world.
Yeah.
The 1%ers, the people that run the world, that everybody likes to think they're the people pulling the strings. No, that's you, bitch. You work at Starbucks. You're a 1%er.
Yeah.
If you work full time at Starbucks, you are the 1% of the world. You're the string puller, but you're not, right? No. No, it's the world's really kind of crazy.
Yeah, it's the 0.001 or whatever it is. Yeah, that's the problem.
Both things can be accomplished if we really directed our resources in a kind, moral, and ethical way. We would solve that first and then get everybody excited about solving the cosmos.
Yeah, it is kind of ridiculous that in astronomy, we used to always be completely federally supported. There was some private funding, but by and large, it was pushed and pulled by federal grants and federal money. And I think that's generally healthy, right? Because then it's everyone can apply for it. It's not about being mates with Jeff Bezos or being friends with certain high influence people.
Right.
But we're getting to this stage increasingly where private money is having a big influence, even in astronomy and other fundamental sciences as well. And then the people that succeed end up being not necessarily the Einsteins, the most brilliant people. They're just the people that have the right connections and can pull the strings and we're on the island at the right time with that kind of stuff. And that's just kind of gross.
It's gross, yeah.
It shouldn't be that way.
It's also gross that humans can control resources. I mean, think about all the problems that they have on Earth that are directly a result of someone wanting to control natural resources. That really should be everybody's. Mm-hmm. If we were really smart about it, we look at the oil's clearly everybody's, the water's clearly everybody's. We should all agree that all the stuff that we need should be everybody's.
The air, yeah.
Yeah. It's like to charge you for air would be wild, right? But you can charge you for water, or they could charge you for oil. It's kind of crazy. It's kind of crazy that we have allowed that system to be in place where an individual can literally be in control of the blood of the earth that we use to make plastic and electronics.
Yeah.
And that's where we're at.
Right. So when you get that, if you do go to, I've never been to space, I've never had that, I've certainly seen clear night skies, but I think when you look out, you see not countries and boundaries. You just see this, we're all in this together.
That's what
on
everybody
this tiny
says.
little fragile thing. This is it. Like we could fuck this up so easily, but we could also make it so glorious if we work together.
That also gives me pause about this whole idea that the aliens are like space daddies come to keep us from blowing ourselves up. Like that might be like very idealistic thinking. And if they don't exist, we're on our own.
That's the God delusion, right?
Right.
It's like it's wishing for that fatherly figure to come down and teach me the error of my ways and look after us. And that's just, look, the cavalry ain't coming, Joe. This is it.
Right.
It's on us. It's on our skin to solve this freaking problem.
Well, I was like, when the United States was about to bomb Iran, I was like, okay, well, now we're going to find out.
Yeah.
Let's see if the aliens step in and go, hey, cut the shit. They didn't.
No.
Maybe they only step in when you use nukes. Maybe they have like a threshold of acceptable aggression that they allow.
Yeah, I don't think there's any backstop. There's no backstop.
No, I think it's up to us.
Yeah.
I think we have to figure it out. But I think we're all aware of that, and that's kind of the cool part of this whole, the weirdness of this experience that we're going through, is that it's not guaranteed, and that there's a bunch of struggle that really has to take place. There's a lot of thinking that has to take place, a lot of talking, and an understanding, and a recognition that some of our behavior is totally illogical. And
Most of it.
A lot of it, totally counterproductive. But like, why? Like, why are we still behaving like territorial apes? Like, what is it? Even though you're not, and I'm not, Jamie's not, like a lot of people aren't, it's not everything. It's not every interaction that humans have.
Yeah.
But it's enough that it's still pushing the worst aspects of our life, which is war and poverty and crime and violence. It's still pushing all those things.
Yeah. But I mean, it's hard because, you became like the top podcast, and because there's competition, and that competition probably drove you to make the podcast better and better and better. And similarly, as a scientist, we're in competition with each other. So there's almost a catalyst system embedded into science that I want to not like crush my enemy or something. I'm not trying to crush the other scientists, but I certainly I know what the level field is. And if you want to stand out, you have to, bat above that level. And so that drives me to become, I'm definitely influenced by competition. I feed off it.
Yes,
and it makes me a better scientist when I know someone's breathing down my neck at my data. I'm like, that's it. Let's just crank out the hours. We're going to do the best we can. But if I know no one's looking at my data set and I've got 3 years to myself, I'm just going to chill. I'm just be like, there's no urgency here. Let's think about other things. Let's do other stuff. So that competition, like you said, is really double-edged. And I don't know, we need to figure out a way to channel it because, I did martial arts as a kid a lot. And one of the things I really
What'd you do? Which style?
I did Taekwondo, I did a bit of Muay Thai, and I did some Shotokan karate, but mostly Taekwondo. And I learn a lot from that, just mentally about myself. I really want my kids to do martial arts because I feel like it's just a transformative experience for learning how to master yourself. And one of the things I really learned was how to channel negative feelings into something productive. Right, so I was feeling really cut up about a breakup with a girlfriend at the time, and I was just beating the crap out of these punch bags, and I was going training every night, every session I could get my hands on, and then it ended up turning me into this like beast. I was like ripped, I got a six-pack, and I was training with a national squad, and I got pretty decent. And it wasn't like I was aiming to do that, it was just an outlet for this anger. And then I looked back at it and realized, hey, I've managed to turn this negative thing into something really productive. And I've tried to, whenever I have those kind of feelings, I always try to twist them in the same way. I remember when I first arrived at Harvard, I had the same thing. I arrived at Harvard and all the names on the corridors were famous professors. And I was just freaking out. I was like, fuck, I've got to have coffee with this guy, these legends. Like, how am I going to like handle a conversation with these dudes? And I remember I was kind of like a bit of an outcast because I wasn't in anyone's group at the time. And I remember walking down the corridor and hearing them laugh at me, saying, oh, here comes the moon. I heard there's a moon guy in the group or something. They thought the idea of looking for moons was crazy. So they're all kind of laughing. I came around the corridor and, kind of like, it was kind of awkward. And I felt like they all looked down at me, and they probably did back then. And after a few years, I know I earned their respect because I was out publishing them, and I was driven by that competition. I was like, I'm going to show you. I'm going to prove to you how good I am by publishing twice what you publish. I'm going to do better science. I'm going to do more of it. I'm going to make myself so good, you can't ignore me. It'd be ridiculous to ignore what I'm doing because I'm so far ahead of you. That's what I wanted to do. And I got to a point where I knew they wanted me in their group now. They were like, oh, come join our group. And I didn't let them get close because I knew I performed better when I play that game in my head that everyone's against me. It was just sort of a mind fuckery. And it's that same, I get it, yeah, same thing as martial arts. It's like learning what are the tricks, the hacks that make you operate well, but being conscious of it. And I think as a society, if we can do that, there's a hack. Competition is a hack that makes us super productive, but it's just a way, can we hack it and channel it in a conscious way towards a productive outcome?
Yeah, turn it into enthusiasm and turn it into inspiration instead of just be overcome with jealousy and rage, which is what happens to the weaker of minds. Yeah. Interesting enough with this podcast, I don't think of it in a competitive way at all. And I never have. And I think that's one of the reasons why it's successful is because this podcast, even though it might be the number one podcast, it's cooperative with, I don't know how many podcasts. A giant number of my friends do podcasts. I promote their podcasts. I have them on. I'll do their podcast sometimes. We all promote each other. So it's a
community.
I mean, I don't know how other people do it, but I don't do it that way. I think only about what I want to do. And I think the only way to have all of your resources, all of your concentration, and all of your efforts put entirely into the subject matter and what the conversation is going to be like, you shouldn't be thinking about anything else. You shouldn't be thinking about results. I just think about process. That's all I think about. All I think about is like, okay, he's going to come in. What are my questions? What are we going to talk about? And I'm excited about this. I'll listen. I'll drive my car. I'll listen to the sauna to things. And I just really get worked up about it. But I don't do it for competition. I do it because I think I'm super lucky to be able to do it. And I think it would be a horrible misuse of that fortune if I didn't treat it with respect, if I didn't do my best every time I do it. So I just do that. And that's it.
Yeah. But from the martial arts, that you must have a competitive drive there, right?
Yeah, but it's not in podcasting.
Yeah.
It seems like it would be because that's the thing I'm the most successful in, which is kind of weird. I'm competitive in everything, but I'm very competitive with myself. I'm very self-critical, which is one of the things that I learned from martial arts is if you don't have an accurate assessment of your abilities and you think you're better than you really are, if you can't see someone do something, oh, that guy's better than me, then you're missing out. because you're also missing out on the opportunity for you personally to get better. If you're delusional and you think you're better than you are, maybe you won't work as hard, or maybe you won't correct some of the errors in your technique and maybe your approach and your tactics. You have to constantly be improving this thing, and you have to have people that are better than you that you train with all the time. So that sort of cooperative thing that came out of martial arts, where you need killers to become a killer, that helped me so much in comedy, because my approach to comedy was different than most of the other comedians that had television deals and movie deals. They all wanted to be the man, and they wanted to be at the top and kind of keep everybody else down. There was a lot of that going on. There's a few people that were cooperative, but I was ultra cooperative. Like, I would prop people up. I want them to get better. I'll tell them how to get better. I'd help them. I'd help young guys. I'd go on the road with people funnier than me. Like, I wanted it, because I know from martial arts, this is the only way. You don't get comfortable and get better. You got to be like really uncomfortable a lot of the time to get better. But that getting better is the ultimate. That's what the goal is for everyone, and it can't just be for you. If you have this short-sighted idea, like I have to be the king, like, no, you're missing out on the whole thing. The whole thing is you need a bunch of kings. You need everybody to be awesome, and then we all rise together. That's how it has to be.
Yeah, in science, it so often goes both ways, though. It's the same in comedy and science. I mean, you think about Isaac Newton, who was famously such an asshole, that guy, right?
A lot of comics like that, too. Big name guys.
Yeah.
Famous guys.
Gets to the top and then spends most of his subsequent career just crushing other people down, right? And there's that need to be singularly recognized as, I want everyone to see that it's just me and it's only me. But there's the scientists I think we all admire and get on with the best, actually the ones who are collaborative, who like comedy, like share and want to do it together. So I think there's a lot to... Sometimes comedians and scientists should interact more, I think. When I was a student, there used to be this thing called Fame Lab, and they used to get stand-up comedians to come in and teach scientists how to talk to the public, how to do scientific communication. And they said it's the same... I don't know, maybe you disagree. It's the same kind of thing. You have to have the kind of the balls to stand up there and just put yourself in that situation.
It helps if you have an English accent.
In comedy?
No, talking about the cosmos.
That probably helps.
It does.
In comedy, it doesn't help.
It could help. It works with Jimmy Carr. It works with Ricky Gervais.
Yeah, that's true.
You know?
Yeah, they've got it.
There's a certain air of respectability that comes with an English accent. It doesn't come with an American accent.
Yeah. So I think there's a lot to... public speaking is something that a lot of scientists... It's the same, because there's so many brilliant scientists and they just can't... They can't
that's
handle
unfortunate.
this kind of situation.
And then there's so many people that call themselves science educators that don't really know what they're talking about, and they're talking about science. And these are the people that are like the figureheads.
Right.
Unfortunately, instead of the actual people that are doing the science. Yeah, it's a skill. I mean, it's a skill that anyone can learn. If you can talk to a friend, you can talk to the public. You just have to learn how to do it, and you have to get better at it. It's not impossible. And yeah, you're going to have anxiety, but that's a challenge that you should just embrace that challenge and get over it. And just have notes and be prepared and practice, just like everything else. Like, if you're intelligent enough to be a cosmologist, you're intelligent enough to talk publicly in front of a bunch of people about cosmology. And you're going to have a certain amount of enthusiasm that you're going to have to figure out the right way to convey it to people to make it infectious. And that's where it gets complicated, because some people are brilliant, but they're bland and flat. And, I'm sure you've had professors like that, right?
Yeah.
And they're brilliant, but they're just like, oh, my God, I'm droning out with this motherfucker.
I've slept through a few lectures in my time.
Yeah, and then there's people like Carl Sagan who are just fascinating to listen to the way he talks.
Yeah,
magnetic, the charisma. It's a thing. It's a factor, you know? It's not the only one, but it's a thing. It's a part of it. And
but you think you could teach someone to be Sagan-esque?
No. I think there's, you can't teach someone to be Dave Chappelle. But you can teach them to be a better version of who they are, for sure. And then extroverts are extroverts and introverts are introverts, and it's just like you're not going to be the same person as Jim Carrey. You have to be that guy to be that guy. But you can learn how to better express yourself, and you can learn. There's techniques. There's an understanding of how the human mind that's interpreting what you're saying. How are they perceiving this? Are they perceiving your emotions? Are they feeling? Maybe there's an anecdotal story that you can bring out with passion that connects these people to you, so that they can understand what made you so locked into this idea. And then they'll go, oh, and then they feel it instead of just blandly reciting facts and just doing it because this is the way you do it with your coworkers and your peers.
Yeah, I learned that through YouTube. You know, I do a lot of YouTube communication. And when I first started the channel, I remember I was copying. I was looking at other stuff that I see was doing well, and I was trying to like transplant that style of video onto my own. And it wasn't me. It was kind of like too animated, too, you know, I'm more of a chill person. And this was like, hey, let's talk about space. You know, that's just like not, it doesn't jive with me that much. But I put it on. And then I was doing this for a while, and we just kind of flatlined in subscribers after a while. And I was like, I think I'm going to pat this in. But before I do, I'll just make 1 or 2 videos the way I really want to do it, and then I'll stop. And so I made these like super deep dive, and I kind of opened up a little bit personally. And you have to be a little bit vulnerable to let your, you know, I'm a romantic. So I wanted that romantic element of astronomy to come out. You know, why am I so passionate about the stars? What are the deep questions that move me since I was a kid? Those, you have to let that personality come out. And once people realize why you personally are so fascinated by this, it becomes infectious, right?
Yes.
And then they start to get the same bug. So yeah, I learned as a communicator that certainly being willing to be vulnerable, it feels very strange as a scientist to talk about vulnerability and emotional connection, but unless you let that in, it becomes dry. It becomes inaccessible.
Yeah, I think there's a lot of truth to that. And I think that applies to almost any kind of public speaking, whether it's stand-up comedy. I think it even applies to music. You know, when someone is singing the blues and you just know that they've had some heartache. Yeah. Like I always said that's one of the reasons why Janis Joplin was so good. When she would sing "Take a Little Piece of My Heart," you believed that. Yeah. You believed it. Like it was coming out like that. That's a lady that's experienced some pain.
I was thinking with Alanis Morissette's.
Yes.
That Jagged Little Pill.
Oh, yeah.
Me and my dad talk about that album all the time. Like, there's so much rawness in that damn album. Yeah. You can't imitate that.
Yeah, you can't imitate that. And you can't imitate that with comedy. You can't imitate that with anything. But I think you could teach people how to do that when they talk about science. It could be taught.
Yeah, find their own authentic voice and use that. Because no one wants to see a copy. Right. You want to see something fresh. That's what makes it exciting.
Well, and then the beautiful thing about YouTube and putting out your own content is you can figure that out on your own. Yeah. You don't have to get molded by executives and some, show business type people that are going to turn you into a version they think is going to be most marketable. You could figure, and people will probably they would probably tell you to do it differently. They'd probably tell you you got to have more energy, David. You got to wave your hands around a lot.
That's why I don't do those shows
wear a
anymore.
Bow tie.
I used to do a few of those, and I got sick of it for that exact. I remember I was talking about a supernova once on camera. I won't say the show, and the director was behind the camera. I was like, can we just try? No, bigger, bigger. And I was like, that's not what I'm about. Can we just bring it down? And I think being on YouTube's great because you get to just authentically talk the way you want to talk.
You'll find an audience, I mean, the people, when I first started doing this podcast, everybody was telling me, you can't do 3 hours. It's too long. I'm like, why not? Just don't listen to the whole 3. I don't give a fuck. I'm just going to do what I want to do. This is what if I'm talking to Graham Hancock about ancient civilizations, we're not going to talk for 20 minutes, man. We're going to talk for hours and hours and hours. I'm like, what else? What else you know? I'm interested. As long as I'm interested.
Curious. Yeah, that's what makes it good because you're engaged with the topic. So
and this is the beautiful thing about this time that we live in, that people can just start a YouTube channel and just talk about things that you're fascinated by and things that you're knowledgeable about. And then people track to it.
It is kind of sad that kids label YouTuber as the number one job.
Well, they influencer, I think, is the number one job.
Now?
Yeah.
Because it used to be astronaut, right? For astronaut. Yeah, president astronaut. And now YouTuber or social media star is like, my kids both have little YouTube channels. They're obsessed with it. Every day we have to do a premiere of one of their videos they've made around the house. And it's definitely influenced kids now. They aspire for that. But it's has some great elements. It's creative. It's an outlet.
As long as you can keep your shit together. Because the interaction with that amount of human beings is also very problematic for young people. Yeah. Because just social media, we talked about this the other day, the Jonathan Haidt's book, The Coddling of the American Mind, that shows self-harm, particularly among girls, the suicidal ideation, all the different things that happen to them, anxiety and depression, all rises with the invention of social media. That's times 100 when you're putting out content.
Yeah.
And then especially if you're reading the comment section and reading Reddit threads and reading your emails, that you're going to deal with so much hate and so much anger and so many frustrated, sick, mentally ill people that are reaching out trying to destroy your life for no fucking reason whatsoever. And if you're a young person and you don't know how to like put this into a rational you're not equipped for it.
Yeah.
No one is equipped for it. It's not normal. It's not a normal type of interaction to have that many people commenting on you and your life.
Yeah.
And so that can fuck kids up, especially if they're like really young and they get into that, and that's like how they develop as an adult with that kind of attention. I just think
my kids' channel is only me, I think, that watches this, unfortunately. And I think, but you're totally right. I mean, the feedback loop is potentially really damaging. And I'm so glad that I grew up in an era without cell phones.
Yeah,
right?
me too.
I can't imagine how I would have got through life if I had Twitter at my fingertips or Facebook or whatever it was growing up, because that just adds a whole new stress. And there's, you hear these stories of kids at school where, the boys like saying to their girlfriends like, well, you need to send me photos of you, and then they get these photos and they send it around the school as a joke, and there's all this kind of weird fucked up bullying going on, and we didn't have to deal with any of that shit growing up. Like it's so much simpler. I mean, my son was saying to me, oh, I'm friends with this other kid at camp because he's got 100 subscribers, and that's become a thing, right? Like how many subscribers or followers you have sort of forms like a popularity rank in even real world settings, and it's messed up. There's so much pressure on the kids in a way we never experienced. And, the more cognitive burden you have like that, the less you can focus on the things you're truly passionate about and discovering what you want to do in your life. Yeah.
It's going to be very challenging for these kids. It's going to be very weird.
Now ChatGPT's adding an extra virtual girlfriends or whatever they'll probably have on there. And
it gets weird. Listen, man, thank you very much for being here. I really enjoyed it. It was really fun.
My pleasure.
Tell everybody your channel, how they can watch your content.
Yeah, sure. My channel's called Cool Worlds. Bit of a mouthful, Cool Worlds. So you can head to youtube.com/@coolworlds. We also have a podcast, the Cool Worlds Lab podcast. And if you want to support a real research program, that's my team, the Cool Worlds Lab at Columbia University. You can just head to coolwordslab.com/support. Cool.
There it is.
Yep. Head over there, and for the price of a coffee per month, you can actually support real astronomy research.
Beautiful. Thank you very much.
Yeah,
Let's do this again sometime.
Yeah, that's fun.
Thank you. All right. Bye, everybody. This episode is brought to you by Simply Safe. We go to doctors and dentists for checkups for a reason, to make sure that everything's fine and to tackle anything before it turns into something bigger. If you care about your health, it's a good idea to seek out preventative care. But did you know that you can also be just as proactive when it comes to your safety? With a Simply Safe home security system, you can get peace of mind and take action before something happens. It's not just an alarm that goes off when an intruder breaks in. AI-powered cameras and live monitoring agents can detect and deter suspicious activity. They can speak to people in real time, turn on spotlights, and even call the police. You can get a lot of use out of their systems. There's a reason Simply Safe has been named Best Home Security System of 2025 by CNET. Try it out. They have monitoring plans that start at around $1 a day. Plus, get 50% off your new Simply Safe system with professional monitoring and your first month free at simplysafe.com/Rogan. That's 50% off with your first month free at simplysafe.com/Rogan. There's no safe like Simply Safe.